Now you guys gotta let me know if my sweatshirt brushes up against the microphone, because that's happened in the past, and Octojay's gotten very, very mad about it, because it makes a very big noise. All right, let's put this stuff away so that we have some desk space, because I'm gonna need, we're gonna need everything I got today. We're gonna need an entire electronics shop in order to figure this one out. It shouldn't be that bad, but I'd like to do it very professionally because it is my anti-lock brake system after all. All right, 3 bins, 1 for each of these things. I'll put all this stuff away. This is Lee Majors, by the way, once again. Lee Majors, question mark? It's a Philadelphia experiment DJ and also an actor. It's not the same person. Not the same person. It's not what you think. Oh my god, the layers of boxes and stuff are starting to pile up around me. I haven't had a lot of time in the past day to get organized. We took the puppy to a puppy training course, and she was a very good girl. She was extremely good at the training course. It wasn't a group session, it was an individual meet and greet ahead of time, because I guess they want to make sure that, you know, your dog isn't going to lash out at all the other dogs. But she takes to training very, very well. She's a good girl. But we learned a couple things. One of the things they stress is immediate recognition of doing something that you want them to do. So like as soon as they do something you want, you go good, like right away. And one of the trigger words is supposed to be yes, but the people I was with, they didn't think yes. They thought yes would be too awkward, which I don't think so. I think going yes when the dog does something good is good, because you're trying to separate that word out from the English language, and you're trying to make it a trigger word that says a reward is coming now. So if the dog does something good, you go good, and then the dog's like, all right, I get food, and then you can go and get the treat and then give it to the dog, because their attention span fluctuates. It'll just go away like immediately. So that's a big lesson. There were a couple different tricks that we were taught in order to make sure that she's following you properly on walks and stuff. There's one where you lead the dog in sort of a semicircle and then you have them sit next to you. And I did that while we were on a walk, and she heeled. She followed me in a heel position for like a little bit until she decided to poke in and start looking at some of the foliage. Pretty cool. It was kind of amazing how easily manipulated the dog would be. But I guess that's why we have dogs. Because they're good boys and girls. They're good puppies. But yeah, anyway, dog's been great. She's been teething a lot, so she has had the urges to bite everything and literally anything and everything ever. But she's doing well. She's doing well. And then I'm falling into a schedule with her. In February, I'm gonna have the dog for 2 weeks just on my own. So we'll get her down here, we'll have her hanging out down here. Hopefully she'll settle down here a little bit. She doesn't seem to need to like look out a window during the day. Just trying to get all of these parts into the right bins, because we'll start working with these soon. And of course, the parts for BTS came in, so we'll work on that. We'll have a Friday BTS session. These are just a little too big for the tweezers, aren't they? Rewind. When a part is larger than the tweezers, what I do is I stick my finger in the tweezers, and that opens them up just a little bit, and then they can spring in and grab your part with just a little bit of force. I wouldn't normally trust the spring force in the tweezers to grab the part, but just by sliding my finger back and forth on this thing, I can stick a part and unstick a part to the tweezers. That's one of those little techniques that people don't really teach you. But it only works in some instances. It's only when it's slightly larger than the jaws of the tweezers. If it's significantly larger, too much force. And obviously if it's smaller, then you have to pinch them. But it gets a little tiring because it's claw grip that I have going on. I mean, the other way that I could pick these up is just by doing that, but I grab them with my fingies. It's a little uncouth to be grabbing these things by hand, getting all the poop particles on my hand on the electronics. You know, the ample poop particles that I have covering my hands at all times. Anyway. Ta-da. Okay, those are contained for now. We got to make a DIY test bed for those so that we can figure out whether or not they're locked down. And that's either using the Jeff link or using an actual J-Link device, which I have coming in the mail. I didn't pay full price. I paid for an eBay special, so we'll see whether or not I get bit in the ass on that one. I just don't want to spend $300 on a debugging interface I'm never going to use. I don't really use debuggers like that. Maybe I should, as my projects get more and more complicated, but the problem with J-Link, it's a great system, it's just so expensive. And the hardware is well, just the hardware. I mean, you got to buy the hardware. That's really where they're getting their money from. Which, you know, if they built a good product, I'm fine supporting them, but $300 and something, just to see if a bit's locked? I don't think so. So initially, at least, we will be getting the DIY solution. These are all trash, by the way. I don't really want any of the other components on this thing. They're all too small. Too small. So goodbye, 10,000 circuit boards. Don't need the silicon mat today. We absolutely do not need hot air today. So the hot air is going away. Goodbye, hot air. I got plenty of that. Over here, haha, get it? Hot air joke, hothead, ha ha ha. He's just speaking hot air. Ha 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 ha. Ow, I just poked myself with a multimeter. Okay, we don't need the big vise, to my knowledge, yet. What else? Don't need the little vise, to my knowledge, yet. Tweezers, we're gonna need. Knives, we're gonna need. Flux, we're gonna need. We're gonna need 4 times the detail. Power supply, I don't think so. I don't think it's gonna be necessary to hook this thing up digitally and test it. I think we might be able to, though. I might be able to hook it up to the CAN bus and with some jumpers. Maybe we could remote into the unit and get a code scan on it. I think I gotta give it 12 volts, though, if we do that. I have to look at the pinout. Pinout is known. It's a very known pinout, so we can check it out if we need to. All right, silicon mat's away. Here's the ABS unit right here. That's the star of the show. This little thing right here, cause of so much strife. It's such a little thing. Multimeter, I guess I'm gonna put off to the side, but we're gonna need this later today. Once we open this sucker up. First things first, though, we gotta actually create the hot knife, which I don't have. So I don't want to get plastic dust all over the internals here. So while not a clean room operation, I would like to keep it clean. I'm gonna get my sweatshirt off. It's starting to get a little sweaty in here. Boom, 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 boom. Yeah, my chat room is from last stream. Oh my god. It's so sad. He has no viewers. People will filter in. It's alright. That's not working. Alright, I got this. I got this. Don't know how useful this is going to be honest. It might be useful. We might be able to utilize this thing. We'll have to see. I mean, if, you know, if I could make the, this thing work. I don't know if that'll get us back there. No, not really. That doesn't really help. Blades and knives and blades. Am I out of blades? I'm out of new blades. I gotta go get them. I mean, I could use X-Actos too. I really don't like X-Actos though. I'd rather use scalpels. Scalpels are much better. Let me get some scalpel blades. I think I have to get these scalpel blades where I stored them was on the tool, the wooden tool chest that's like there. And I think I bumped it and it fell in between the 2 desks. And there's a lot of scrap sheet metal right there. So I gotta go crawl around on the floor to try to get the package of blades. You can buy these blades by the bushel, the non-sterile scalpel blades. You can buy them by the hundreds, which is what I did. Hot knife would be nice to have if we can make that work. It might be able to open up the omnipods more easily too. Oh, here's that special flux too. I don't think this isn't for aluminum, but this is some pretty gnarly stuff. It's for like stainless steel. Might be able to use that. All right, gotta get all the way back here without cutting myself. Ah, and I did. All right, I succeeded. Sweet. I need to do like a memorandum on batteries around here. I need to get rid of all the batteries that I'm never gonna use because there's a lot of them. And it's probably a little hazardous. I'm inundated with batteries that I'm never gonna do anything with. Let me get this clean, since it's a bottle of flux. The bottle of flux has just sat on the shelf for years, but this I use to attach stainless steel stuff together. I don't know if that'll work for what's in here. We're a ways off from that, so I'll just put that aside. Where's my Windex? There it is. I'm gonna clean off this module so it's free of grease. That pervasive automotive grease and dust. And I don't want to shake this thing around too much because all these solenoids are just flying on their leads. All these guys. We'll talk about that in a minute when we get started. Ugh. Somebody's just flying through frequencies in this song. Yeah, got some frequencies for you. Or it'll be right over. It's a Roixop intro. Way long ago. Nice clean bench work, and I'm covered in grease already. That's the way it goes. Just the way she goes. You know what's cool? Having a speedometer in your car. That's cool. It's pretty cool. It's almost as cool as school, you know, going to school. That's cool. I don't have a speedometer right now because this thing is here. This is where all the sensors come in that do all that stuff. I don't have a speedometer. I don't have cruise control. I mean, that should be obvious because cruise control requires a speedometer, but still. And then an old soldering iron tip. Here's an old one. This is an old blue tip? Yeah, old blue tip. That's got a decent amount of energy behind it. The other ones that I have are new. These are new. And I think those are the only ones I held on to. Okay, so that's what we got. We don't have like a like an overdrive tip, one of the ones with a larger heater on it. I don't know if that'll be necessary for a hot knife. Let's see what we got. What's in here? Bunch of shit that I don't use. You know, this thing I've never really used all that much, and it's probably pretty useful. You put a probe in it, and then you lean the probe up against what you want to keep contact with. We just haven't had that kind of circuit board testing in here. These probably would have been useful over the weekend. These are a little bit sharper, finer tipped. I'm gonna actually use them today, to be honest. I have a replacement set of high voltage probes for my normal probes, and then I've got an old set of high voltage probes for my normal probes, and I need to convert these into like pin probes so that I can use lead wires with them. But yeah, this is all probe stuff that I haven't swapped to. These might be particularly useful though. Just seeing these having this really sharp tip that's thinner. It's actually not, it's the same size as these leads. These are another one. But again, these are thicker. These are larger tips. I need something that's like needle thin. Oh, those are poking out of the back of the bin? What's going on here? Yeah, all right, that's pretty good actually. Ah! All right, what else do we have? Glue stick, no. Loctite, no. More X-Acto blades. Let's put those all together, because I don't need them anymore. I don't know where I got them all. Don't use them. Scalpels are the ultimate. There's a flux pen. I don't think that's going to do us any good. I got another thing of flux in here, and then my circuit board trowel. This thing is great. This is a tile cutter. So this is for etching, making like etching or printing tiles. What it has is a little V groove in the front of the cutting blade there. And that allows me to cut traces on circuit boards definitively. So if you can get this thing to cut a good edge, you gotta really position it and be careful. And then you scrape across and it makes a nice little V groove that will sever a trace. So it's really good for circuit board troubleshooting and repair. Really, really good for that. That's all I have to do. Hard pressed. I mean, this is stainless steel, so I don't think I'm really going to be able to machine it very well. I think maybe we just need to staple the two things together with some hardware. Metal, obviously, hardware. I've invented stuff for scalpel blades in the past, so I don't think it'll be too bad. I don't think it'll be too hard to figure out, but give it a little longer for people to show up, you know? It's a Thursday. Everybody's kind of getting rolling here. I'm a couple minutes late, so the people who are usually punctual have probably gone off in other directions. What's up? Nothing's working. How's it going? Have you ever dealt with one of these evil Bosch units? These things are kind of evil. What is this? Switching diode. What is it? All right, my 4148s. I gotta put those somewhere. Huh. Just found it. It's just like under something. These ABS units are evil. They really are. It's like Bosch decided to like use an experimental technology. It really wasn't experimental. It's actually kind of a known thing, the functionality of this stuff, but they went with the technology that they didn't really properly vet out in an automotive scenario. Never touched any ABS units apart from replacing brake lines connected to it. Yeah, this is the control unit for the ABS. It's a doozy. It's a Studebaker. I mean a doozen. I don't know. I don't fucking know. Why are you asking me questions? Yeah, it's gonna be kind of a beast. Hey, our dimensions were right. That's pretty nice. Look at that, beautiful. Now it's all in black plastic and black painted metal, so it's impossible to see on the camera. But those will give us our little hooks that the top piece will be able to clip to. So that's pretty good. Probably can't use the wood hardware on these because these screws will poke through. Yeah, but it'll just be like just like that. That's be pretty cool. Can't wait for that. It'll look pretty fancy. Silver clasps probably would have looked cool too, which I had a kit for, but I think I threw them out. So I went with a black paint on them. Silver would have popped off against the contrasting, you know, black. Although I could print this in silver, but then with the wood and the black, it would have been better to do. Nah, I don't know. Silver clasps, dark wood. That would have looked good. But with the black there, it'll emphasize the clips less. Even though that side of the thing is kind of boring. But we want to understate the control box as much as we can. I mean, there are LEDs sitting right below it that'll give us the statuses of all the voltages. Speaking of which, I do have this stuff from Pololu. Check this out. Check this out. Bada bing. They come gold, brass. Gold would be pretentious. Brass would be more scientific. So box comes from Pololu. right? My address is on the underside of it. This is not in a different box. This is like how it came to me. And then instead of a bunch of packaging plastic, it's just a piece of tape holding everything in the bag on their little light box. Brilliant. Very well done, Pololu. Very, very well done. And it's a pretty weak piece of tape, which is nice. And those are powerful. That landed label up. You know, like, just one thing I asked for, not to get fucking doxxed by every single thing in this building. All right. So these are our 2 voltage regulators, and we may need to figure out how to cool them when we put them in burn the subs. We'll work on this tomorrow. Toss that out. Gimme. I don't know which one is 5 and which one is 12. This one is 12. We'll keep the 5-volt one in the packaging for now. This is gonna make a brilliant amount of 12 volts for a thing. I'll be nice and efficient in doing it. I'm gonna 1 inch by 1 inch square. I'm gonna sneeze. I need to vacuum in this place. Copyright 2019. Oh boy. Yeah, so this is a 52 volt input, 12 volt output voltage regulator, and it's got all the pins in a line there, and they're 0.1 inch spaced. So if you want to, you can hook this thing up on a perf board, although you won't want to do power ground and enable probably on the same line. But V in doubles up, ground has 4 pins, and then V out doubles up as well, because this is a high current regulator. Now, those capacitors, the capacitors there, are taller than the chip. The chip is going to be dumping a ton of heat out on this thing. This gets hot. This thing gets hot during operation. So with this thing doing a 24-hour vigil on our system, I'm wondering if we need to put, I mean, we can put a spacer plate on that. Probably need to, because that capacitor's right there. Maybe just an open air heatsink, or we can tie it to one of the rails that goes right by there. That means that if this thing fails, I then have to, first of all, order another one, and then burn the subs is going to be down for a day. These were expensive enough that I didn't buy extras. I don't have extras of these things. So from a systems engineering standpoint, this is a liability. I haven't had these fail yet, though. I have one on my steering wheel, and it was really, really good. So with any luck, we will be okay. We also have an enable wire on there, so if the power goes out, I can see on the system control panel that this thing was the fault. But like, so I wanna cool this thing a little bit, not like, it's not gonna be a complete necessity, but with it running that long, I don't want it to be too warm, because I think that'll lead to wear and tear on the circuit. So we can either do a little spacer. I'll probably, maybe one of the Raspberry Pi heat sinks if it fits on there. The height of these components might be enough that just a little piece of thermal tape is enough to push the height of it up so that I can get a piece of aluminum on it. And then, of course, open air will just, you know, natural convection will just cool it inside of the enclosure. Because the enclosure is mostly open. It's just kind of hidden. The openness of the enclosure is like sort of variable, but whatever. Cool little thing. These are like $20, $30 boards. So they produce quite a bit of power. They're buck regulators, and they're pretty goddamn efficient. You can look up the efficiency tables on their website, but that's Pololu that's selling these. I like Pololu. Pololu makes a lot of cool stuff. They're sort of like the shortcut to the robotics stuff that you need to put together robotics. And I mean, technically we do robotics here. So cool. Put that aside. All right, we get started. About 30 minutes in. I don't know. I'll give it a little bit more. I want caffeine to kick in. I went to bed at like a little bit after midnight last night, which is really weird for me. What's up, Smelf? Good to hear from you all. There's one person in chat, Turbo. It's one person. You got in a little bit. I guess people will start filtering in. Oh wow, everybody's here. It's like one guy sitting in a chair, like looking at his phone. What do you mean, all of us? Oh, I need the other leads for these. I need my other leads. Where are my other leads? What happened to them? They're not there. Where they have gone? Other leads. Let's make some noise. Make some noise out there in the crowd. And the one person's like, shut up. Where are the specific multimeter leads? Ah, here they are. Yeah, that's the ones I need. We're getting sharp probes. This stuff is weird that we're getting into. It's a Proteus. Let's see. What else am I gonna need? I'm gonna need something that's gonna hold this knife at a level with this edge. Renee is deciding to remain silent. I would like to hold it at a consistent edge, but we don't have to have that. I mean, I could just, you know, deal with it. I could just have a steady hand, which is not necessarily something that I can promise. I guess I can accomplish it with that. But I might need to lift up what I'm cutting. Want something like this. It'd be like that, and then you'd cut across this with this held in place. Everything has to be held in place. I don't know how that works. I'm not sure how that's gonna work. Unless I clamp it down to the desk surface, which is something that I could do. Oh boy, I'll explain all of this logic in a minute. You know, why I'm thinking on this particular brainwave. We have our jobs cut out for us today. You know, ow, I just stabbed myself with a probe. You know, like, as soon as I start talking about how professional I'm trying to be today, I accidentally stab myself with my own probe. We haven't tied the knife into something chat controlled in quite a long time. See, what I don't like is these universal probes. They've got this whole setup on the back there that you hook it up to, and now it's like a mile long. It's okay. I mean, it's all right. It's got a nice tip to it and everything, so. Oh, dear God. It's got a lot more of a tip than I gave it credit for. Get these off of here. Just put this in the background. We're not gonna need it yet. But when we do, we do. When we need it, we need it. I needs it. This is Lee Majors, by the way, if you guys are interested in this music. Obviously, this is a fairly recent mix. This is a fairly recent mix that he did. Here, let me pull it up to the front monitor. We can see precisely how old this fairly recent mix was. This is from 11 years ago. Okay, maybe that's not exactly 11 years. That was 1990, right? 11 years ago, not 2010. Anyway, Lee Majors, he's part of the music collective and the Philadelphia Experiment. There are people who do a bunch of parties around here. I like playing the music. They got good mixes. They do a lot of what do you call it? Tech house, which is good background music because it's like 4 notes at a time. You don't get any more than that. Everyone's watching. Oh, is there a PC gaming show going on right now? Oh man, I'm missing out on that. Now let me know if there's anything cool. We're just excited to play Halo once they get all the kinks worked out. I really wish they would get Halo 5 to the PC. I know they're not exactly pushing for it. They want to forget that Halo 5 exists, which is really sort of disingenuous of them because it exists. It's part of the series, even if it is terrible. I want to play it. Thought Lee Majors was an actor. Yeah, I know. It's not that Lee Majors. It's not that one. If you want to see a good B movie, look up Lee Majors. But Lee Majors, Question Mark is apparently a DJ. I didn't choose the name. Don't blame me for it. I clean my glasses. I got dog snot on them. Took the doggo, took the little corgi for a walk before stream. We were out there and it was windy, like really, really windy. So we're walking towards the back of the neighborhood where there's some woods, and we heard a tree fall down, like huge crackling, ground shaking tree fall down. I didn't see what oops, there's still a spot on my glasses. I didn't see what fell. I was looking around for it. I didn't see anything. Could have been a branch leaning up against a tree at that point. It might have been one of those deals where the tree is like basically two branches and one of the branches splits off. But there was a lot of crackling and a lot of thundering crashes out there. Pretty crazy. Pretty crazy. Yeah, the Twitch numbers update sort of at weird intervals. So while I'm sitting here like going, oh, 12 of the people watching me, my popularity is dead. I'm a failure. And then the next second it updates and I've got like 28 and I'm like, okay, all right, never mind, it's fine. You just got to shut up about numbers. That's the thing. That's why it's kind of rude to tell a streamer how many people are watching, because it's like, dude, you don't want to act differently depending on the number of users that are there. Although chat interaction is a very large layer of what I do here, so I don't know. I got most of the stuff collected here. It's just that we need generic metal hardware, and so that's going to require a lot of fishing through. I almost said fisting. It's going to require a lot of fishing through bins and stuff in order to gather up what we're going to need. And it's not really going to be all that complicated. There's a possibility that I'm going to need to use the drill press, and I would say milling machine, but I think drill press is the better thing to say, since the drill press is going to allow me to make plates that will be threaded that will then carry the knife blade. Now I'll explain all that again. I'll obviously say it all again. We need to find like generic parts. This song is starting to piss me off, actually. Hold on. Stop it. Shut up, song. I dislike it when the song has just like a repetitious like in the background, because you're like listening to it and you're like, and you're like, what was that? Was that like a ghost or something? And then it happens again and you're like, that's like a ghost. There's like a ghost in this track, right? This music is fairly guilty of having that happen a lot. A never-ending Limbo song. Yeah, I just don't like when the 4/4 is too apparent. Especially this whole category of house that's just like echoing voice lines. It's like a waking nightmare. All right, we gotta change it up. We gotta change it up. This isn't working. I'll try to find new music for next time. I'll try to find something different for next time. I'm sorry. No, the music's gonna make me start now. The music's gonna make me start now. I can't be asked to find a good mix. Maybe we'll go back to DJ every day. I don't know. Let me just stop it straight up. Bonk. Okay. Hi. How's everybody doing? Washboarding isn't working out. The song breaks and he will. I'm gonna have to reevaluate that sentence when I can read it and understand what it says. Yeah, everybody's out watching the PC gaming show, but we have our work cut out for us today, chat. I'm a little worried about what's about to happen. And there it is. It was everything I was afraid of and more. IndXC, thank you for subbing for 19 months. I appreciate that very much. You guys are wonderful. My Twitch payout is dwindling over time, and it's just the way it is. The channel's not growing, but it'll grow with this thing. So we'll get back to burn the subs tomorrow. I have a bunch of parts. Unless this drags out, we'll get back to burn the subs tomorrow, and we'll get a lot more work done on it. I've got everything I need to finish that power supply and a couple considerations to make for like heat. Anyway, what are we working on today? Today, I need to work on my anti-lock brake module. I put that sensor back in, the one we tested on Tuesday. Put the sensor back in, and I unplugged the giant billion-pin connector from the end of this thing, which is right by the exhaust in the middle of the top of the engine bay. Unplugged it, put some probe leads in there, tested, and I got the exact results of having a wheel speed sensor attached. So one thing that we could have done, and I kind of regret not doing on Tuesday, was stuffing a 9-volt battery into a little enclosure with an LED and just putting a comparator on it so that I could have something that I could plug in and test the sensor to see if it was sensing wheel speed. It would basically be the comparator would trigger the LED when you get over the voltage threshold. And you can control that either with a potentiometer on a voltage divider, or you can do it with a Zener diode so that you can get the exact voltage that you want. And if you get to that voltage or above that, then it'll illuminate the LED below that threshold, and it will turn it back off. That's as simple as it gets, right? It's one chip, 9-volt battery, some diodes. We could have done that, and that would have been a nice little peace of mind, because I don't know if after all of the effort that we spend today, the problem is still going to be where I think it is. There's not much to the ABS module. If you guys know, on this series of BMW, Volvo, and some other car companies that use this Bosch system, there is an ABS module, what is communicating on the CAN bus. And the ABS module gets all of the sensors first. So it gets the angle of your steering wheel, the pressure on the brake pedal, an accelerometer, I think is like a tilt sensor. I don't know which tilt that is. And then it also gets 4 wheel speed indicators. And the wheel speed indicators are similar to, but not exactly, a Hall effect sensor that is sensing a cogwheel on each of the spindles. So as your wheels turn and your steering wheel turns and your brake pedal slams down and the child gets closer and closer to your bumper, this system can then say, hey, this isn't right, something's going on here. This wheel's slipping, and this is happening. So then it can start to activate 4 solenoids on each brake line in order to pulse the brakes, and it's also got a pump in it too. It's got a pump to create brake pressure. It will then evaluate how to keep your wheels moving a little bit so that your car can instigate the trajectory that it needs to go in, as well as slow it down at the maximum rate that it deems possible at the time. It does a lot of stuff, and it's a lot of good stuff to have on your car. It probably also tells the throttle to slow down too. It's like, hold the fuck up. So yeah, that is your basic ABS module, and this is a circa 2000, 1999, 98 that these things are in effect. This Bosch module, yeah, it's a lot of math. It's a lot of stuff that it knows how to do. But so this module was in quite a few cars, and now all these cars are starting to get up in the mileage. The problem is Bosch invented what they consider to be a high temperature ABS module, and that way it could exist inside the engine bay where things get hot and cold all the time when you turn on and off your car. All those heat cyclings they said that their module was not susceptible to, and they could make it work really well. Problem is that now that all these cars are at this sort of high mileage realm, they're all failing, and all the failures are in all the exact same places. And we will see why in a little bit, but it has to do with the way that they built the circuit board substrate, bonded it to all of the external connections, and then used a gel on it. And the gel is probably their big mistake, because they have these hair-thin, microscopic gold bonding wires that I think have been piezoelectrically bonded. I think it's larger than just a regular old push-down gold wire bond. It's like they had something come down and vibrate it in order to get it to sort of cold weld. Problem with that, when you surround that with a gel and you put that in an engine bay, is that the gel, you can think of just like a Jell-O mold jiggling around, right? A Jell-O mold's jiggling around, and because you have those gold bonding wires, they're supposed to be ductile and flexible and stuff like that, and deal with the heat and cooling cycle. But when they are in an engine, which is in a car, which is going over gravel, it shakes. Everything shakes all the time. And so with it shaking all the time, it's flexing those wires over and over again, and you get metal fatigue, and especially so at the bonding site, because you've got the pressure of the gel coming back and forth on your stuff. It all wants to move differently. So unfortunately, that's what we have to deal with. We have to deal with an insidious gel, and then we also have to deal with microscopic wires, wherein if we clear an area to repair a wire, it can displace the ones next to it and damage them. I'm gonna spell this wrong and everything's gonna go fucking psycho. I'm gonna get all kinds of bad results. So yeah, this right here is why my anti-lock brake system doesn't work. This is it. This is the reason. Now, we've only ever seen the gel substrate on one other thing on this show. We've only ever seen that gel substrate in one other thing. The one other thing that we've seen it in is a solid state relay meant for industrial purposes. We took one apart because I think it was dead. Wanted to look to see if anything had blown up. And we found a ceramic circuit board that was encapsulated in jelly or gel. It's like a gel substance that keeps out the environment. That's all well and good for a controls cabinet, because a controls cabinet doesn't fucking vibrate. A car, on the other hand, if you put a gel in a car, it's like this kind of crap, you know? So what happens there is inside, all those little gold bonding wires are subject to all the movement of this, and it leads to breakage. Here's the problem, though. Problem, though, is that this thing is incredibly well environmentally sealed. I don't know if there is a good way to open this thing up, and the only way that I've seen the Shade Tree Mechanics open it up. By the way, I could spend like $200, and I could send this off to some people that would pop it open, do the repair, and either send me back this one or send me back a new one. But if I get a new one, that means that I have to code it to the VIN number of the car, because it's part of the, I guess the ABS system is part of the like lockout system for security or something. But I have to code this with the VIN number, then I have to calibrate it with the steering wheel angle sensor and some other stuff. I don't want to do that. I think that's kind of a pain in the butt when I can spend a couple hours with you guys and we can sit here and try to get this right. So what I would like to do is repair my own, and that requires opening up this top piece. This unit attaches to a block that has all the anti-lock brake lines going into it. What the ABS system has are a bunch of these little pokey out thingies that are fitted to each of these coils. So each of those pokey out thingies hits one of these coils. The coil activates a solenoid. So sorry, it was 3 each. Yeah, 3 for each. I don't know what they symbolize. I don't know exactly what they do, but they're in charge of probably switching the steering pump motor or the brake line pressure or the I don't know, the individual wheel on and off. I don't know. Probably works like a switch, like normally open, normally closed. I don't know. Either way, this thing fits up against just a block, and it's got 2 contacts, 2 big. There are these big finger contacts that come forward and contact these 2 circuit board. Circuit board. This is in the era of cars that don't actually have circuit boards in them. Instead of circuit boards, they just have a plastic substrate and then metal as the different traces. It's kind of a hardcore way to do it. I guess you don't really need to go buy circuit boards then, and you don't have any of the shortcomings of circuit boards. You got all the high current stuff of having just a big plate of metal that sort of routes your power around. So I think these are ground contacts, but then all these coils and the motor are controlled by another circuit board. You would think that they would give you a way to get to that circuit board by removing all this stuff, but because it's of an era where they are constructing things by injection molding, this stuff is all permanently attached. So if I were to remove as much as I can here, basically I'd be able to get rid of these 2 pieces of metal, and then I don't think I'd be able to get any further than that. I think they're molded in and or just plastic tab welded onto the enclosure itself. No, to get to this specialty circuit board, we have this cover right here, and I need to somehow figure out a way to remove it. Now, if we look closely, which I have the ability to do, because I'm me. If we look closely and we get good lighting on this thing, there is a gap there. We do have a seam, and the seam seems to be filled with something. Oh, get it? Seams? Seam appears, there we go. The seam appears to be filled with something. Well, a hammer and a chisel is how I think the Dutch got into this. The Russians, I think, used a long, flat saw blade. I, like the later entries in the forums that I was going through, would like to use a hot knife, because I think it would be a much cleaner cut. So this seam right here looks like it has some kind of an epoxy in there. I don't know if I could get, like, necessarily a tool in there. If I could get, I don't have this particular X-Acto blade or particular scalpel blade, but there is a scalpel blade that's like a hook knife. I wonder if I could get that in there and actually like work away at this. Well, I mean, I might as well just try something first. Oh, that's epoxy. That is epoxy. That ain't gonna, yeah, that ain't gonna give up. That is a little bit beyond what a guitar pick can handle. I'm going to leave behind metal if I do that. I was looking up, what do you call it? I was looking up piezoelectric blades, too. That would be another way to try. No, I don't think this is going to do it. So the way to do it, in my mind, without... Because remember, there's a gel inside of this thing, and so I don't want debris in my gel. Cleanest thing we're going to do is heat up this blade to the point where it's going to displace the plastic and melt it. So we'll heat it up just like a soldering iron tip and just run it along here until we've released the top. And as long as I don't go too far into it, we should be good. Now, the hot blades that I've seen other people use are much thicker than a scalpel blade. They're like a thick, like, chisel tip. I don't have any blades like that. I think this is all we get. So we got to give this thing a shot and see if we can do it. The heat gradient across the tip is going to be pretty extreme when we do it. Now, like I said, scalpel blades fit onto this sort of like square machined... Oh, let me get a view of that. Well, maker beam stuff is in the way. I got to move the light really close today. So this is all going to fit. I mean, the scalpel tip fits on sort of this flat thing. This sort of flat thing. The problem is, I bought this with the intent of making this into a hot knife blade. I don't have a flat edge on the back end. I could put it in like on the grinder and get that to be flat. I don't know if this is really going to be all that effective, because one thing about these scalpel blades is that they've got like a big slot in them, right? They got the big slot in them like this. So we could just put 2 screws on that and hold it down to some flat piece of metal. The challenge then is to get that to attach to the tip of one of my soldering iron tips. This one's out of commission. This one doesn't work all that well anymore. So I decommissioned this one. Now, I'm not sure if there is a temperature sensing element in the tip itself. There probably should be if this thing is worth its money, worth the $7 that I spent on it. But it might be contained in here. I would much rather be using one of these guys, one of the ones with the larger prominent heating element as part of the thing, because that would, I mean, if I could somehow get these two to mesh, that would be kind of beautiful. That would be a brilliant thing indeed. But anyway, we're going to try to figure it out with what we've got, and we'll see if we can attach this thing to a blade, and then that blade can whip off this top. We'll see. Where do I even start with something like this? Holy shit. I mean, really, I've got all kinds of like tools and stuff that can help me with this. I've got the milling machine too, if we really need it. I think I need to find like pieces of metal that I can use on this. Because what would you do? I mean, you would what? Take one piece, drill a hole that's a little smaller than this, take a slot cutter and cut it in half? That doesn't really make any sense. I think you use screws to kind of pinch this thing together. One thing I don't want the tip to do is to move, right? So I really need to kind of lock it in. Metal. Metal would be the start of this whole thing. I've got a bunch of scrap all over the place. Let's see what I can find here. See if I can find anything that like would lock down to the tip of a soldering iron. I don't think I have anything that can already do that. I think we just need to add screws to something, and I think it'll be able to accomplish that feat. That's like a miscellaneous, like a bracket. Eh, not quite. Not quite my tempo. Let's see here. Got a bunch of water cooling stuff. That's not going to help. That's not going to help at all. We could 3D print. No, we can't. This is outside of the realm of 3D printing. I don't think I trust this task with aluminum. So I've got to grab... I don't have a lot of non-aluminum in the shop. Aluminum is sort of the mainstay because of the small milling machine. The small milling machine is not as great with, what do you call it? Not as great with hard metals. Because I mean, it works with them. It's just the soft metals tend to kick things around a lot less. So, let's see. Oh man, there's a lot of scrap in here. But none of it's really like steel. I guess aluminum could work. I think it would wick away heat too much. Although transferring the heat is kind of the goal of this device, right? Of this little hold down that we're about to make. That's aluminum. That's more aluminum. Aluminum, aluminum. Oh, what are you? You're light enough to be aluminum. Aluminum, aluminum, aluminum. Have I found a singular piece of steel yet? No. No. I guess steel sheet will work too. I think there's some... Is that... What are you? What are you down there? You come back here. I got you. Oh, it's aluminum. Fuck. Damn it. I don't know if I have... Well, that's definitely steel, but it's like a fucking 1/4 inch thick. It's like ridiculous. I could mill that down, and because like we're talking about like a tiny little soldering iron tip. This is way over the top. This is way over the top. This is unacceptable. What else do I have? I got stainless steel. I got some stainless steel brackets for the maker beam stuff. What else in the hardware department? In terms of like, I got those. Well, those are zinc-plated, zinc-coated steel. I don't know if I want that on the heating element. Machine a screw and a bolt down? Nah. I have a soldering iron that is exacto tip screwed in where the soldering iron tip was. Well, that's what we're trying to build, except we're going to use a scalpel tip. I mean, if I look up, like... Yeah, I mean, it's not like something couldn't have been purchased. It's just I want to fix this thing and I don't want to spend $1 billion. A lot of the suggestions were to Dremel the top off, and Dremeling the top off creates dust, and that dust gets in the gel. So, how to make an improvised hot knife? Put your lathe. Okay, they're starting with a lathe. That's the first problem. And they're using an X-Acto knife. These are two things that I just cannot stand. Two things that I just can't stand. We are gonna have to use the mill, but oh, so they made a screw-in pressure tip for the soldering iron? That seems even more dangerous than it should be. Well, they're doing what they could with what they had. And there's the slot cutter. Yeah, I don't like this at all. This is what people want me to do. This is what they want me to do. This is how they want me to live my life. There's absolutely no way that I'm going to trust that thing not to come loose. Hell, even what we're going to make is going to be kind of worrying. It's going to be kind of worrying. This is the block of metal I was talking about. This is like way too much metal. You know, I just need like a little tiny plate. We could make do with that. That could actually work really well. Let's get the knife over here. I mean, this is like real cheap stuff. So this will probably blue really easily too. Let's see here. So if I were a scalpel blade, I'm not saying I'm not. I'm supposed to tear this way. Let's see here. My Aegis. Oh man, Index C just subbed too. 29 months. It's not my birthday, but it's 29 months. Hell yeah, dude. Hey, thank you. Thank you, my Aegis. Thank you for the subs. That is very kind of you. Hold on, I just check something. Yeah, cool. All right, so scalpel blade is a brand new blade. These aren't very blunt blades, but the further up we can get the heat, the better. I mean, that would be nice, but I don't think that's going to happen. Even mounting it back here like this is going to be kind of difficult. Let's work on getting the camera in focus, huh? So if I can attach this to one side and this to the other, I guess we'd probably be okay. Where's my focal point right now? It's like right there. Okay. So these 10A blades, I mean, doing it like that. Problem is there's so many overlapping attachment points for this, and I don't know how far down this cartridge goes. I don't know how far down the heater is. You know, I'd love to get the heater to be right where everything happens, and it's probably at the top of this shoulder, but I don't know if it goes up into the tip any. I've had a couple of these break on me, but take an extra job at McDonald's and whatever. How about you stop coming up with stuff for like a minute? Yeah, it'd be much cleaner if I just had a block that could screw this thing onto it, or had, you know, this, and was somehow able to lash the tip onto it. How do I get this thing out of here? I don't know how to get this thing out of here. Hold on. I mean, could I just like... This is like a spring post. Weird. There, done. How does that stay in there? What is holding you in there? Is there like an invisible pin? Maybe it's like pressed in. Okay. That's even more out of the question. Yeah, it's a shame I can't somehow, you know, just lash these two together and have them work. Because if I cut, I guess I need the whole thing to hold the blade. Oh, this is going to be great. Oh, good, it's fighting me. That's always nice. It's always nice when there's like a little bit of debris to fight the blade going in. There we go. So if I could somehow get that to work with the heater, which would be like down here. I don't really think I can get a drill bit in there to work, because I need the whole thing. I need all the way down to here on this thing. What's up, Copper? Usually it doesn't fight that much, you know? Usually it's a little bit more behaved. So this meet this and somehow get along. I mean, if I could just drill a hole in the back of this thing, that'd be kind of difficult to do, just because I don't think there's enough metal there. It kind of is, though. But then somehow getting it to apply pressure and hold in will be fairly difficult to do. And then how far does the heat carry into this? It'd be the easiest thing for us to test right now, though. If I just lop off the tip of this thing, I'd have to cut it. I would have to take this and just cut it like right there. So I guess put this in the vise. I have the side cutter in there right now, and I might be able to get that to cut this. It's still stainless, though, so as I cut it, it's going to be annealing. And that's going to pose quite a few little problems with the whole process here. It'll probably dull my blade, too. Get this in the vise. Get the vise here. I don't know how I can... I'm not going to hold this while I cut it. Have to attach the rest of the thing in order to hold it in place. I don't think this is a good idea. Yeah, stainless is really obnoxious. This is supposed to be so that if you want to like cut stuff at a weird angle, you can do it. Oh my goodness. Look at me. I'm cutting at a weird angle. But if I set this thing up to be straight up and down, like that, hold it, cut that tip off, put this in the vise, very carefully position a drill bit to be in the center of wherever the most metal is, probably the back end here, cut that. There's no way for me to put pressure on that to hold it in place because I don't have enough room for a screw back here. Unless I did, well, okay, wait. Cut the back, bore this out, put a grub screw on it. Okay, all right, I'm in, I'm back in. Let me get the blade off of this thing first off. Step 1, render it not lethal. Okay, let's see what we can come up with here with the milling machine. So I'm gonna move the light over. I think we can do this with a grub screw. I hope. I really hope. Because I need the hot cutter in order to get into this thing, right? God, there's no light over here. We need to fix those lights. I think I've got it set up slow enough right now that we should be able to work with it. I just need to clear some stuff away from the milling machine. The milling machine has been the victim of the shop mess over the past couple weeks. So let me just get things kind of put away around here, and then we'll start with the milling machine and see what we can come up with. I think I have everything that I need in order to put this into effect. Please don't fall into the fan. That laptop has all of my car coding stuff on it. Yeah, can we tap stainless steel? I mean, we have to be able to, right? I have the nice taps, and we're not tapping it very far. It's a very simple operation. We should be able to get away with it, right? It's not like we're doing big machining, and it's not like we're doing high volume anyway. And we'll just tap it straight through the whole thing. Be better if it was steel, but I don't think they sell steel scalpel holders. There's the word. There's the word. I gotta clean out these bins. These bins are full of crap. Bunch of crap. Oh, that's a heavy one. Ready? Oh, Jesus Christ. A lot of plastic in this one. I gotta free up some room for me to exist. Now, there are some clips in here that might work. Like for the, well, not quite. All right, hold on. This one's all carbon fiber. That's obviously not going to work out for me. Although, I'll have to remember those are there. There's some brackets in there that might help us out. Okay, so milling machine partially opened up. I got to clean up from last week. Yeah, I mean, I think we've all been there, and it's not like I'm blind to that effect, you know? This'll take 5 minutes. It'll be easy. I know what I'm saying. To a degree, we need to experience that around here. You know? Can't be good at everything, but you get good by trying. Working with stainless steel, I believe, and I could be talking nonsense here. Correct me if I'm wrong. You need to go slower with everything. Everything needs to go slower, and that way you're not heating it as much, I guess. I think you enjoy misery. Not really, man. This isn't that bad. It really isn't. Part of the show. Yeah, there you go. All right, so what does she here? Got plastic dust all over everything. Tap set right there. All kinds of garbage needs to be moved out of the way from working on car stuff. This is for the Omnipod system that was going to allow me to get the circuit boards out in a fairly easy manner. And it didn't really work. Mr. Copper, I found a button shiny and purple, so I clicked it. 12 months of Prime. Mr. Copper, thank you so much. Use cutting oil. It's easier to tap after. Okay. Every task is much harder than it should be now that you've gotten older. You should be getting better at stuff, not worse. Things should be getting easier, man. Or at least maybe you're getting more critical of your own work. This jig was a rousing failure. It was awesome. But that was a bad idea. I should be vacuuming is what I should be doing. If one doesn't trip at least once near the lathe because of power cables, oh my god. I don't know, man. Well, first of all, I don't have a lathe, but I also have wires all over the floor, so I mean, maybe you're not wrong. I just listen, I've seen so many videos of lathes doing things that they really shouldn't do, like eating meat, that I don't like lathes. I really don't like them. I don't like them at all. I don't want to have one. It's also a huge waste of space around here. I'm gonna get a little brush so I can brush everything off. This is sort of the end. The milling machine is sort of in a hangover mode between a bunch of little tiny weird attempts that I've made to do stuff with it. The DRO doesn't work, so that's been kind of a limiting factor. It needs to be vacuumed off. We need to take the whole thing apart, and I need to re-grease everything, readjust everything properly. I'll look up the adjustment procedures for everything, because there is one. There is a documented adjustment procedure for this whole mill, and we can get all the greases right and everything, and then it'll be a fully functional mill once again, and I'll be happy to have it. But we need to spend the time doing that. That needs to be something that we do soon. Put the vise back in a normal vise mode. We had it gripping on the outside edge. That's very much not what we need for this. Lathes are just horizontal mills. There's a little bit more to it than that, though. They're pretty dangerous. They've got the cable up in the ceilings, so it's hard to trip on it. Oh, that's nice. Yeah, having like a power run on the one of those cages that you can run wires in. That's nice. That's nice. That's very, very nice. Nicey nice. Okay, that's good. What I should be doing is foofing it with actual compressed air, but I don't have that right now. I don't have compressed air, all right? Our goal here is to make a tool that will allow us to open up the Bosch ABS module. The Bosch ABS module is sealed together with epoxy. It was never meant to be opened, but you can open it and you can do minor repairs to it if you have an entire electronics shop with a microscope. What we'll find inside is going to be very interesting, I guarantee you that. But first we need to make the tooling that will allow us to do the job that we need to do. Why is this not seating? Why is this weird? Why are you weird? Probably because of the wrench. I gotta open this up a little bit more. We need the front jaw of the vise. What is going on here? Oh, this thing just refuses to align properly. I guess I'll loosen the other one. Yeah, these jaws can be moved to the other side in order to grip things. We did that for the keyboard project, which is, again, another project that we didn't quite finish, and I would like to get back to. Did I cross-thread this thing already? I don't think I did. Nope, there's just a little something in the threads at the beginning. I gotta make sure this other face is nice and clean, too, because there are going to be microscopic deviations of the two jaws now that we've removed them and put them back in. That's another thing that needs to get meticulously adjusted with a lot of gauges and stuff like that to make sure that everything is nice and true and square again. Because if you can't trust your work hold downs, what can you trust? Those aren't going anywhere because there's oil on the surface. Oh, wow, and it's like a really badly ground surface. Wow! That is a rough surface on the front there. Wow, you can feel the individual, like tool teeth. Ugh. It wasn't an expensive vise. Let me tell you, this stuff might look like it's nice and pristine and expensive, but none of it is really high quality. There's a discernible difference between the high and the low quality of this kind of stuff. Can I get to the back of this thing with this hex key, with this T-handle hex thing? There we go. That, come with me. So yeah, what we're gonna try to do here is lop off the tip of this scalpel holder, and then we're gonna try to drill a hole in the back of it that's going to press fit the tip of the soldering iron, and then we'll try. Notice how everything is try. We're going to try to get a grub screw in the side of that thing. It'll be a small grub screw. Small grub screw indeed. There's not a lot of room for a grub in this town. Grub in the big city. Now this doesn't, I mean, this is like drill press work that we're doing right now, so this doesn't need to be incredibly super duper dialed in and clean and accurate, but I just don't want to put this thing back in shit shape and then be doing another shit project and have that shit translate to my shit. So I'm trying to get all the chips away, all the little pieces of plastic away off of the oil that's on these things. We will come back here at some point soon and refurbish this entire thing, because I've had it for like 6 years and I haven't done anything to it, to adjust it, to tune it, anything like that. I just basically took it out of the crate, took it down. My buddy Krigor and I lugged it down here, and we put it on an engine hoist and put it up on the table. So this thing weighs about a little over 350 pounds, and I've added some stuff to it too over the years. So it probably weighs a little bit more than that. So it's not something I can just pick up and move. But if we do it piecemeal, if we take it apart piece by piece until it is in component parts, then I believe we will be able to work with, you know, all the component parts. All right. Really should look to see if I can rebuild my super old bench vise. Yeah, those are very satisfying projects. These sim rigs are getting more realistic every time. All right. I'm not adding ABS to my sim rig. Damn it. Is this the best tool for the job? Is this the only tool that I have for the job? Yeah. Okay, where's the thing that we're cutting? This thing is going to be very awkward in there. I do have this thing. Question mark? Hello? Where did it was right here. Oh, there it is. I got one of these things, and this is designed to hold circular objects, so I can put that in there, and that'll help hold it in place. This thing isn't going to be exactly calibrated to be straight up and down. I want to cut it this way because it'll let me get closer. I mean, this side cutter is on kind of a big piece. This thing is not exactly a small radius here. It's going to be difficult for me to get close in. Do I have anything else that can hold something like this? Nah, no, not really, no. Nope. I could also, I can't really get it over the edge. That doesn't really work that way. That's not how mechanical things work. Bother. What's wrong with you? What's wrong with you? Well, this is going to be comical and or deadly. I'm pushing the knurled edge into the vise. That's not good. And then this thing isn't exactly straight up and down. We don't need the best cut in the world. Actually, I can put a bar underneath this, and that'll straighten it up. Get just something like this, just one of the parallel bars. Just put that across. There we go. That's a little bit more civilized. And then flatten that like that. I could also cut it straight towards me and, okay, whatever. Yeah, we'll go this way, actually. That'll let me line up the cut better. Now, which direction is this? This thing moves this way. So we'll want this on the other side when we cut it. Because you want it to be pushing the piece out of the jaw. Or pushing the piece away from the cutting element. There we go. All right, that's holding on. Stupid things that I do for stream. Part 1. Section 1. Chapter 2. Let's see, the head's not going to move. The table is, so let's move that like this. You guys got a pretty decent view of what I'm going to be cutting? I don't even know if I'm going to be able to cut it with this thing. That thing is so short. I've seen a rig with an electric motor connected to a clutch and transmission to attempt to make it feel more realistic for the clutch pedal and gear shifting. That's kind of cool. That's kind of cool. I mean, you see all the people making the setups that use the brakes. Those are kind of cool. Use actual brakes with calipers and everything sometimes. Should we put a blade on this thing just to make it kind of like interesting? You know, a little friendly wager. Can I keep my eyebrows? That is barely going to be able to cut in on this. Well, you only live once. Just about there. Now, is that level? No. Literally nothing has been adjusted on this. I'm just trusting that this stuff is moderately square to itself. Cut it lower on the swivel point. I can't get in. I mean, like, if I had... I don't have a side cutter that's that big. That's the only problem. I have a diamond wheel, but that doesn't bore. This doesn't bore in. I think those are the only side cut wheels that I have. Unless magically I find something in the drawer right now. I could put a stone wheel on it. I mean, yeah, I could put a stone wheel on it. That would actually be okay. That would actually be a thing that I could try. No, I don't have any other blades. I don't got no other blades. So it's this or nothing. I could always try to Dremel it. My CB handles diamond wheel. Oh, so that was you in that truck stop bathroom. All right, so power that on. Turn it on. I'm just gonna slowly... Let's move it forward. Or no, back. Yeah. Back and then this way. My God, something's gonna explode. How did I do? I put a mark in it. We slotted aluminum with this thing really nicely. I don't know if we're just dulling it now. We might just be dulling it. Yeah. I think we have to use the Dremel on this thing. I think it's Dremel or bust. I didn't clamp it as hard as I guess I could have, but I didn't want to damage any of my stuff. What do we end up doing? Oh, we made it slightly smoother. Oh, that last pass actually cut something. Look how embarrassing this is. You ready? Look what we actually did here. Look at this. So all that noise didn't cut anything. That last little bit cut something. I guess I could use that as a guide for the Dremel that I'm inevitably going to use. Son of a bitch. I hate using the Dremel though. I hate it. We got to protect everything in this shop now from the Dremel. Stupid Dremel. We'll use Dremel. Dremel will do fast work on stainless steel because it does fast work on everything because it's a stone wheel and it's just going to shave away the layers while making an incredible mess out of the rest of my shop. But then we'll have this tip piece and we can bring that over to everything else. Stupid. So let's get, number one, a larch. Let's get the Dremel. And then I guess I need like a cardboard box or something that I can work inside of. Now, I guess I could use the Dremel to open up the Bosch unit, but that would be an incredible mess, and I don't want to have to deal with that. So let me find a cardboard box. Find a cardboard box that I can work in. A nice cardboard home. And the wheel, which is a new wheel, which I've just put up here. There it is. Yeah, Dremel's company. It's a rotary cutter, or whatever. Why is that even like interesting though? I need to buy more Dremel wheels. I get the ones with the carbon or the what is it? The fiberglass reinforcement. The water pick of non-aqueous material. What the fuck? Do you have a contest to be the weirdest comment that I've ever read in my life? I think you guys do. All right, let's see here. So this was put together on this seam right here. Oh, I fucked it up already. I don't know. It's not a lot of cardboard, but I need to just mask where I'm cutting so that all the overspray, quote unquote, doesn't get into everything. Because the last thing I want is just mess everywhere. And it's not really even the metal that I'm worried about. It's the stone that's coming off of this thing. So I'm making a splash guard out of this case. That's pretty good. Okay, so like that. Turn the light around so we actually get some light over here. There we go. I was using this thing to disassemble the omnipods because this type of bit is really good on plastic. It's just like a little knurled rod. It's got just a lot of little cutting. It's basically an end mill, but for plastic. It doesn't end up melting stuff a whole lot of the time, although some of the time it does. Probably should use the big vise for this, but I'll use the little vise. I'll use the little one. Fucking Dremel. Fucking hate fucking Dremels. Fucking piece of shit. Fucking fuck. Making me plug it in. You gotta plug it in, you know? Stupid. All right, get this thing going. I'm not using the anti-lock brake system of my car as an armrest for dremeling. This goes somewhere safe. There's nowhere safe in this shop. There's absolutely nowhere that I can put this thing. I'll just put it right there. That's totally not a safe spot. All right. Of course, there's like a hair right there. Actually, let's do this. That doesn't work better. That doesn't work better. Blame Joe Biden. Okay, do that. I thought everything had 5G now. It's too low. It's too low. I wanted a flat surface so I could get a good cut. It's too low to the ground for my Z plate. That's going to create spray everywhere, though. I need it to be closer to my guard. Okay, it runs the opposite direction that I thought it did. Reverse. Change it. Change it all. Change it up. Change it up. Short but cool. What are you talking about? I'm still here. Why am I being weird about this? I don't know. I just want to get like a flat cut out of this thing, and I don't trust myself. You know, most of it's just me not trusting myself to get a good cut, unless I have guides and stuff to like stabilize me. That's on you. That's not on me. Okay, so that's running down. So I guess if I just carefully move this way, most of the dust is going to go down this way, I hope. All right, so there's going to be some noise now. I won't alter the mic. So you guys, if it gets too much, let me know. I don't think it will, though, just because I have a lot of filtration on the microphone. All right, I'm gonna let heat dissipate a little bit because my hand is blocking the air vent on this thing. I don't want to overheat my Dremel. I don't want my stainless steel to get too hot either, because it's gonna work anneal the stainless steel. It's gonna become work hardened, which is not what I want. I want this thing to be moderately machinable. Although, to be honest, I probably should be like, I don't know. What do you do? What do you do? Do you cool it down over a longer period of time to soften it? I know stainless steel is notorious this way. It's very difficult to work with. One of the other things is, when working with the Dremel, is to keep that Dremel moving. Keep it moving at nearly its maximum RPM. I mean, you can go down a little bit, but that work that it's doing is going to start heating up all of the coils inside of this thing, and that's where all the damage comes from. You can even see it just like warming up on the whole body of it. You got to keep the air vents clear when you're operating the Dremel, and you have to keep it spinning, because when it spins, the fan moves, and when the fan moves, everybody cools off. What you can end up doing is severely damaging the interior of your Dremel. Now, friends of mine who are a little bit more bullheaded in their shops will simply run their Dremels ragged, and they go through one Dremel a year. These things have been produced cheaper and cheaper by the year, so the newer ones are really not going to be putting up to a lot of bullshit very fast. This one, I think, is from the early 2000s or so, and I still have it going strong. It hasn't broken on me yet. The one that I have sitting up on the shelf is even older than that. And I mean, part of it is that I never use them, but also it's that you need to keep the motor happy in order to keep your Dremel happy, because it is just a motor. All right, here I go again. Here. Yeah, I don't know what grade stainless this is. It's not a high grade, but we're getting through it. We're almost there. Just gonna let it cool down a little bit again, and let my Dremel get a little bit of a break. What's up, Groove? And I don't know how to say your name, man. Stainless steel is a pain. Yeah, that's been the commentary for the past, like, bunch of time. We're getting there, though. We're getting there. Then I get the wonderful task of, see, this hole's like crooked as hell now. I guess we got to figure out how I'm going to drill this out. Bada bing. That doesn't leave a lot of material for me to put a grub screw on, does it? The things that I deal with. The things that I deal with. It's not a bad cut. I do wish I could have had more material on it, but we got as much as I think we could feasibly get out of the thing. You know, because the cutting blade itself has width. And I couldn't get it out of there because I don't know how it was even put in. Unless maybe like I took a hammer to it. I'm not sure if what they did is they put a pin through that and then they machined like around it so it didn't look like there's a pin in there anymore. So, things I do for love, yeah. The things I do for an ABS module. Ah, it's still super duper hot. Let's let that cool off for a minute. Here, you talk to the aluminum. It's nice and cool. That's our scalpel holder. Now, you might just be tuning in and going, this guy's fucking crazy. You're right. You're right. Everything that I'm doing right now is kind of stupid. What I'm trying to do is attach a scalpel tip to my soldering iron so that I have a hot plastic cutter. Because the way these things were constructed, the Bosch ABS modules, that they put it together using epoxy. And so the best way to get into it is to just simply cut the entire cover of the electronics off. We need to get into it and we need to probe a wire because I believe that there is a connection that has vibrated itself free. These Bosch ABS modules used this weird method that we've only ever seen used in an industrial solid-state relay. Solid-state relay, what the solid-state relay did is use a ceramic circuit board with all the silicon chips just simply deposited on top of it. Right? They just deposited the chips on top of it. They made all the circuit connections using gold bonding wire. They didn't really use solder in it. And then, in their infinite wisdom, because this works in the industriosphere, not the carosphere, what they did is they deposited a gel on top of the entire circuit as an epoxy-like substrate. It's kind of like those chips where they put a big layer of epoxy over top of the chip and you never know what the chip is, you can't work with it or anything. Instead, what they used is gel. And what the gel does is what gel loves to do. Right? When your car vibrates, it does this. Now, it keeps the environment out and everything, but this is what's happening to all of those tiny little microscopic gold bonding wires within the unit. It wiggles around like that, and so the pressure on those wires varies. Now, the gold bonding wires are ductile. They can move around and stuff like that. But even in older electronics chips, you can take the, like if you see there's like a plate that's clearly been soldered on, you can desolder that plate and you can see that the gold wires are just in the air. They're just in oxygen. They thought that putting that gel on there would seal the environment out, as well as the cover plate with the epoxy on it. But what happened is, what happens over hundreds of thousands of miles, it jiggles around. And so those copper gold wires are subject to vibration and they will break. So now here at the 100 and 200,000 mile mark of all these cars, they'll start failing. A friend of mine's been through a couple of these units. You can send them for like $200. You can send them out to get repaired, which is not all that bad. But I want to do the repair myself because I think it's fairly more interesting than just sending something away and being poor. I'd rather do interesting things and be poor. Okay, so that's the dremeling. I really don't want to take the Dremel out for anything else because it creates too much dust. Too much dust. And we want to work in a moderately dust-free environment. Garbage that. Tweezer's back. Oh god, there's still dust all over the desk. Oh. Okay. What are we left with? What's the flavor? Yeah, it's an E39 BMW 528i. Now, these units were used in Volvos and Audi and stuff like that, so a lot of people have gone through the issues with these. These basically have, on one end, it's got one of these plastic floating circuit boards where it's just a bunch of steel plates that take current to the ABS motor, which sits behind this, and then all of the solenoids that control the anti-lock braking system. But the intelligence is in this side of the enclosure. That's where we're trying to get into, because 2 of the wires that take my brake sensor into the unit aren't working. I mean, it's like I've tested the wire. We tested the unit yesterday. It works on the oscilloscope. Plugged it all in, put the multimeter on the pins. I didn't do an oscilloscope reading of that sensor because I don't think it's getting the current it needs in order to function. It needs to get a certain amount of volts in order to function. So that's what we're looking at here. We're going to take a look at all that stuff. All right, so I've got the cutoff piece right here. I need to get a drill bit that's pretty much just exactly sized to this, because what I'd like to do is have that come in at the thick part, maybe just the middle of it, but I can't have it stick up into the top because that's where the knife mounts. Here, let's go slightly in on this so you guys can see what I'm talking about. It's hard for me to pontificate about this stuff without you guys seeing what I'm talking about. This does not need to be a totally flat surface. I probably could have cut that a little bit better. Decent enough. I mean, maybe we could put that on the file, or I could take an end mill on it. I'm probably going to have to. Well, an end mill isn't really going to like the stainless steel. I use the diamond cutting wheel to sand it down and get it to be straight and true with this part. That's okay. We'll put this in the vise. Look at that. It's like kind of crooked. Who machined this? Well, I guess I do have to use the diamond wheel, because we'll use the diamond wheel and I can sand this down to be flat carefully. And then I guess the drill bit's going to have to go through this part here. So we'll have to find that spot, depending on the size of the drill bit, and get that through. That's a drill press task, not a machine task. So the milling machine is also a drill press. And then I don't know what I'm going to do about locking it in place. If it's pressure fit, we can use it for now. If it needs a grub screw, I do not know genuinely how I can find and drill through the side of it properly. I just don't know. It's going to have to be a microscopic grub screw. I mean, if this is drilled out far enough, no, it'll probably just be like that, won't it? I don't know. It depends on how far I think I can get, because I don't want to ruin this surface here, because that's where the blade clips on too. I wish I had more work room on the back end here. All right, well, let's not fuck this up. Let's not mess this up like I did my spindles. First things first, let's clean off the back of this thing and get it to be flat. Flat and true. So for that, I'm gonna put the big wheel on this thing, and this is gonna become a whole weird setup. This is a strange day of machining, guys. Oh my god. I haven't used this in some time. It's gonna be weird. And then we'll get this out of here. Ow! Ow! Stupid blades. These are probably dull from their brief... Yeah, they look dull. Oh boy. From their brief stint machining stainless, I think I dulled my tool. My tool! Oh my god. So we're gonna have to pick apart this entire machine at some point. It'll be kind of fun, actually, to be honest, because I haven't been inside of all of the crevices of this thing. It's gonna be a lot of grease to clean off, probably a lot of brake clean too. I'm gonna asphyxiate myself down here. Probably won't be using so much brake clean. That's probably a bad idea. maybe just some light oil or something. But then I got to re-grease the whole thing and get all that stuff back together. There are whole like parts diagrams of this thing online too. Move in this direction because you guys are over there. Basically, I'm just going to lower this thing onto it very carefully and get a nice 400 grit scrape. Now, how do I position this thing so it's flat? I mean, the tip of this thing is rounded. The sides of this thing are rounded. This is kind of straight up and down, but I don't know what I can... Let me get a parallel bar that I can move up against. And then, yeah, there we go. That's nice. Nice, nice, nice. Okay, so the parallel bar is helping. Now, how do I do this without pinching the shit out of my thumb? It's like, all right, I got a position. Ah, my fingers! What have you done? Hey, now almost an engineer, sub for 24 months. On a month streak. Am I going to get burned yet? We're working on it. Teddy Manator, how's it going? Yeah, we're working on it. We're getting there. Tomorrow we're going to be working on Burn the Subs. All my parts came in. Yeah, we got a lot of streams here where... Oh, wait. Oh, it's not going to work. Fuck. This is too thick. It's too thick. I've only been told that once before. I need a thin sheet that is parallel. That's a big ask for around here. I think about that a little bit. I have that piece of like zinc, steel, whatever this stuff. Oh, but that is a right angle in part of it. Plus, it's not. It's not parallel. Okay, hold on. I gotta find like a moderately square piece of steel or whatever that is thinner than this very, very already thin thing. Thin thing. I guess I could back it up to the edge here and use that edge. But that's not going to be very accurate, is it? Good as it gets, but still. I need to be able to like really wrench down on the vise too, because we really need this thing. When this thing is in position, I want it to stay in position. I have a little square piece over there. That's not going to do it. It needs to be like sheet metal thick. Is my square going to be able to do it? Yeah, the problem's in the ABS module. Unfortunately, the ABS module is the fault here. The cables were perfectly fine. And I tested them on the multimeter. It's not going to work either. Damn. Now I could eyeball it, or I could try to match it up to something above, but the pieces above don't match the pieces below. Like that. That's not going to do anything. I might as well just eyeball it at this point. If I don't have anything that's going to be able to position it straight up and down. Usually the parallel bars are what I'd rely on in order to do this. All the other stuff I have is around. Let me see. Just thinking about what I can use here to get this true. But yeah, the ABS module itself, problem is in this thing, there is a gel that holds stuff, that holds all the like circuit components. Oh, it isolates the circuit components from the outside world, right? The environment. So as such, as a gel instead of an epoxy, it wiggles around as the car operates. And that's not a problem for the first umpteen years of the life of the car. But eventually, time takes its toll, and all of the little vibrations that have been wiggling your car around for so many years end up breaking one of the wires. So that's what we're dealing with right now, is I can DIY this. And in order to DIY this, I have another project that I've been meaning to get to, which is to make a hot knife tip for my soldering iron, because my soldering iron deserves it. I don't know. Just because I wanted to have a hot knife tip on the soldering iron that I can cut plastic with if I need to. So that's what we're trying to build right now. In order to build it, we're cutting the tip off of another scalpel for our hot knife tip. So we're cutting off the tip of a scalpel, and then we're going to try to get a hole in the back of it that will allow it to attach to the soldering iron, hopefully. Now these, we haven't measured these or put these exactly in parallel, so they're actually off by quite a bit. Oh my god, this is really a drill press project. The two jaws of the vise are completely off from one another. Yeah, I guess we'll just send it. So I'm going to squish this down pretty hard. So now that's being held in, and now this is going to make the most awful noise in the world, but hopefully it will allow us to at least straighten out this surface, the top surface of this knife holder, to the rest of the mill, and that'll allow us to drill it more easily. A knife and open fire. Yeah, no thanks. I mean, you may have said it last stream. I don't know. Somebody was here last stream telling me that the ABS module was full of oil, which is just so wrong. People say a lot of stuff during stream. Try to give you guys a little bit more of a view of like what I'm looking at. No, where is that thing? It's like you can barely see it. I probably should have put it on the other end. Well, I can flip ends. I can flip ends. We can swap ends. Let's get this out of the way a little bit more. Now what I should be doing is putting another piece of material in the other end. These are definitely not straight up and down, that's for sure. Holy shit, these things are so far off. I really need to be doing this based on the bottom of the vise, not the two plates that I put on. But I'm gonna eyeball it, and we're just gonna deal with it, whether it be a little bit crooked or not, because we're not spending a lot of time straightening this thing. All right. There it is. Oh, this is gonna be too tall, too tall. Yeah, once again. God damn it. Bring this all the way over here. The bonnet, the little center of the bonnet is too big. Bring it all the way out there. And then I'll focus. All I care about is that that top piece of this thing is level with the, what do you call it? Level with the rest of the machine. This is gonna make a horrible noise. Here, I gotta get in position. Ah, there we go. I don't think I've done, oh, I've only got a little bit to go. A little tiny bit to go. God, it's loud. All right, man, that is loud. This thing could be quieter. One of the things I want to do is upgrade this to being like a V belt, because right now a lot of the noise is created by the timing belt that it uses. Well, I didn't flatten the whole thing, but I got as much of it as I think we need. Worst kind of sound for your ears? I guess so. It wasn't all that high of a decibel. All right, so, because we got the drill shuck on it already. Is this thing hot? No. Yeah, the diamond wheel makes short work of stuff. It's a lot more effective than I really give it credit for. So now I gotta find an appropriate drill bit. Now I would like this thing to be press fit from the start, just because I don't know if I can get a grub screw in it, and the grub screw is sort of like a last resort. This isn't a lot of material to get through, so. But yeah, in terms of drill bits, I mean, the drill bits are over here. Drill bits over here. And this thing, we got to just match up to a drill bit. That one's close. That would be a press fit. We'll try this one first. The first sacrificial drill bit. Now, because I don't have the DRO running, I can't, finding centers and stuff like that is a little bit more difficult, to the point where I'm just not going to do it. I got to find a center on this thing. It would be nice to get it fully machined to the center, but again, remember, I just put the vice jaws back in and they're all cockeyed. These are all over the place. They're just not good. So if we can just get a decent enough pilot hole in this thing, I'll be happy. I mean, of course, I'm going to professionally eyeball the center, but... Well, actually, I should get it started with a one of these things. That'll probably help. This is my super long one. Why is it so long? I don't know. I actually don't know. I actually have no idea. I don't know why. I don't know why it's like this. It scares me. It's so long. It's so ridiculously long. Why? Why are you like this? Why can't you just be normal? All right, so approximately as center as I can get it. And then the width of this thing is going to put us just like right at that mark. Hopefully that doesn't ruin everything. Probably will. Usually these things do. It's just not going to be perfect, is it? It's going to be like right there. Probably is going to bust through the wrong stuff. Well, let's give it a shot. I'm going to lower it very carefully. This is, of course, when I snap this super long bit. And because it's so super long, it gets like a shitload of momentum and fucking takes me out. It just straight up murks me and leaves me for dead. Because that's how it goes around here. This is from such a weird specialty machining job, and I'm just using it as a normal tool. I don't know. I don't know why I have it. Yeah, it's the end part of a scalpel blade holder. Might actually be smaller. Yeah, our tip is smaller. I need a smaller drill bit. Slightly smaller drill bit than this if I want it to be... I mean, it might be kind of press fit the way it is. I don't want it to be riding on the grub screw, though, so I would like it to be a little bit smaller than what I actually have in my hand, which would be this one. I don't know what sizes any of these drill bits are. It's just a big bin full of drill bits. I bought a huge drill bit kit like when I was in my 20s, and I've been using it ever since on various projects. They're like barely even machine quality, and I've lost and replaced and had them supplemented with other stuff over time. It's just a big grab bag. What? Am I going the wrong way? No, here we go. There he is. Royce. Okay. Double check. Double check. That looks a lot larger, doesn't it? Yeah, it is a lot larger. It's still larger. Hold on, I'm not... Nope. Rather go smaller first. Try to find a smaller bit than this. Ooh, I can't touch the machine wheels. It'll end up breaking a drill bit. This one doesn't even look like it's going to drill this material. That's a good one to start with, though. This one does not look like it's going to be very amicable towards stainless steel. We don't have a lot of material to get through, though, so we might as well ruin one bit at a time. Might be looking like the ABS thing is going to take me more than one stream, though. This way I can feel what's going on a little bit better. And what it feels like is that this bit is dull. If not instantly dull. There's still chips coming off of it, though. Why are all of my weird drill bits long? Yeah, maybe we do need a little bit. Just a little something in there. A little 3-in-1. Quiets it down a little bit. Gives it something to soak up heat. There's all kinds of sounds coming out of this now. The thing about the long drill bit here, let's let it cool off for a little bit because it is smoking. The thing about the long drill bit is it gives me an idea that I'm putting too much pressure in it because it starts to distort a little bit. Oh boy, we got a little bit further to go. We just got to let it cool off now because it's, again, stainless steel. We don't really have a choice in that one. The problem with cutting this thing or any other method is that it will interfere with the inside of the chamber that we're trying to get into. The only thing that we've got kind of our work cut out for us in is that we have to get under the big connector in order to machine or cut the wow, that is like a 2mm hole and there's no further progress from there. Huh. I'm gonna need a fairly deeper hole in that piece. I'm gonna need you to go ahead and cut a little further down. I feel like I'm just friction cutting at this point. I think we've dulled this drill bit. Might be that it needs like a pilot out of a different material, like a ground pilot. Maybe I need a coated drill bit. I don't think I have any. Like a coated end mill, maybe? This is an X drill bit. This is now the softest drill bit that I own. It is just simply a friction bit. There's no more progress. Yeah, stainless go burr indeed. I think we drew. I think it work annealed and is now. I now need to regrind the drill bit if I want to get this to cut it all. Plus, I don't know the source of this drill bit, so it could also just be a really bad drill bit. What about like a little end mill that's coated? Because I do have some pretty special end mills that have some nice coatings on them that are very small. But it has to be a coated one, so let me see what I can find here. Well, that's going to be too hard of a cut, isn't it? A 2-flute coated bit like that, and it's also, I think, larger than the hole. Let's get this drill bit out of here because it's a disaster. Can I touch it? Yeah, okay. Yeah, that was just rubbing. I mean, that could work. It's got a weird edge on the back of it though, and it's tapered. I don't just have cobalt bits sitting around, although these I think are. I think these are the end mill stuff is the only cobalt that I have, and I don't have a lot of smaller ones. I think this is the only one that is that size. Just check around in my end mill bin. You guys don't have an end mill bin? This one I think is too big. Oh, this one isn't even coated. Don't always got the tool for the job, you know? Know what I mean? Know what I mean? Know what I mean? Know what I mean? Got the same thing, although this one looks newer. If I use that, then I'm only going to get this far in. And if I only get this far in, it's not really going to hold the soldering iron. I could get another drill bit and try to use it a little bit more sparingly so I don't dull the shit out of it. I had to figure out what angle to grind that on, because that has been dulled to the point where it's now a wood drill. I don't know what to do. I don't know. I guess I could find a similarly sized drill bit and see if that'll get us a little further into the cut. This one looks hardened. At least like it's got something going on. Something's better than nothing. Try it. We'll try it. We'll ruin another one. Keep this over here. This is where drill bits go to die. The shop. Lube. 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 Little bits at a time. Little bits at a time. That didn't do anything. It's not cutting at all. It's just it's just hitting a brick wall. There's no cutting going on at all. This one was probably already dull. Next. Ruin a perfectly good drill bit, huh? That one's too big. Last resort would be to try the end mill. But the end mill's not going to give us enough distance that the soldering iron bit can be sunk into this thing. Now, this is what they mean by stainless steel being a pain in the ass. We might have work hardened the stainless and not dulled the bit. I got a little bit of a cut there, and now I'm going to just sit here and wait for everything to cool off. A bin of screws from wood? Huh? I'm letting it cool off. I'm doing a little tiny bit at a time. I'm scared now. Yeah, it feels like it's hitting a wall. So I don't know how much we have left in us here. I had a buddy who worked as a representative of surgical products. So he'd go to all these orthopedic surgeries and they would end up not using all the hardware that they were given. So he would have a bunch of these body screws left over. And these are like expensive, right? They were all very specialty because apparently working on bones is a lot like carpentry. So you have to figure out what kind of a bite your screw's gonna have into the bone and stuff like that. So he had all these like really gnarly, high quality, like titanium screws in his trunk. So if he had to hang up a painting, he'd use like a $40 screw. It was ridiculous. I put a little bit more pressure into it that time. Are you drilling metal without coolant? You don't always need metal to drill or coolant to drill metal, but I am putting 3-in-1 oil in there. I don't know why everybody tries to call you out on stuff. I'm gonna pop the drill bit if I'm not careful. Smoke. Yeah, I don't know. Stainless, it's not really cutting. Well, that's nice if you have a bunch of like packaged screws that have the labeling on them. It's pretty decent. Yeah, the only problem with drilling stainless steel, and that's what I'm kind of attempting right now, is that, yeah, every time I drill metal, I set up a full coolant apparatus to run on the machine. So I'm spraying coolant all over the place. And then I've got a giant cryogenic freeze finger that I put up against the vise every time, even if it's aluminum. Yeah. I don't know, people jump in the stream and they try to like call me out on stuff. I can't tolerate this anymore. I think this has failed. I think we failed, chat. I think we might have failed. I think that might be what's going on here. I think this might be failure because I'm not getting any deeper into this thing. Yeah, and it's hot. I don't think it's that easy to work harden stainless steel. Just curious what you're doing. Okay, I know. I see smoke too. I do too. But it's just the oil. It's just the oil letting off a little bit of smoke. Yeah, I don't know. I think what has happened here is, yes, I'm not cooling it, obviously. And what happens is at your cutting edge, all that friction is going to create quite a bit of heat. And that heat is going to work harden the stainless steel. That's why people hate stainless steel. It's just a temporary step back. Yeah, I mean, we could put like a Dremel grinding bit in the end and make my way through there while grinding. But I don't think I have one of those like very fine stone grinding bits. Grinding bits obviously don't have to deal with this because they just destroy everything in front of them. That's why we were able to get through the side of this thing with a, what do you call it, with a grinding wheel. That's why the Dremel was able to cut off the whole tip of this thing. But getting a precision hole drilled into the side of stainless steel, it's possible. If I had cobalt, you know, crazy coated drill bits that wouldn't dull from something like this, maybe I could get a little further than this. But I've got amateur tools. I'm not a pro here. You know, we're just a weekend gamer out here on the circuit. So I don't know what to do from here. Not quite sure, because I could burn through all the drill bits that I've got. Right now, the workpiece is all aligned. That's sort of what I'm trying to preserve here. I'm not going to pull it off and do something else with it. But our hole, like not even a millimeter. And why is it going to the side a little bit? That's a little better. So our hole is like a millimeter. Not really making any progress either. Well, I can sit here with a little bit of pressure on it. Yeah, it's not getting me anywhere. No, I need specialty stuff in order to get any further. And that end mill is probably a bad idea. Well, can't really lose much at this point, and I've got extras, so I might as well try it. The cobalt end mill. This thing is going to totally fucking ruin the hole. Because I think once it's work hardened, I think you're fucked. So I don't think I'm even dulling my drill bits because they're just not doing anything. They're just sitting up against the hole. But let's see what happens when I use this little cobalt end mill, this tiny little thing. That actually worked. That actually removed material. Hold on a minute. That little bastard removed material. Let's go back to our small drill and see if that'll get us any further then. Maybe I've removed the work-hardened surface and this will work again. Although it means I got to jump all the way up here. Because that end mill, the end mill's not going to plunge a very large hole. But it did open up some of the material there, possibly giving us more surface to work with. That hasn't been work-hardened. Well, that's lost. I'll get that back later. Yeah, that's actually cutting now. Okay, hold on. We're still in business. Keep adding oil. And just go a little tiny bit at a time. I don't know for how long this is going to work. I don't think that's actually, I don't know if that's actually cutting anymore. It did work it down a little bit though. Unwork harden it. Yeah, I don't have like an oven that I could do that. Never tried tapping steel like this. Good lesson there, yeah. No, we just need the one. I mean, it might be nice to have a side hole. God, that sounds dirty. It might be nice to have a side hole for this so that I could sink a grub screw into it, but that would mean I need to tap from the side. So I think my dog's having a play date outside. See if I can get this one deep enough to hold on to the tip of the soldering iron, then we're in good shape. Yeah, we have the two herding dogs are now playing in the backyard, and all I can hear through the window is they're running back and forth. They're crazy. So I don't, that noise that I'm hearing, I don't know if that's throwing oil out or if, because I see little specks of stuff and it could be stainless steel, but it also could just be oil getting tossed out of the hole. I don't know if I'm making any progress. It's just like the end mill ate this thing alive. I think I need to get cobalt drill bits. There's absolutely no way in hell that that's making any progress at all. That was just oil flying out of the top. The only thing that ever did any damage to this was the end mill. How deep is this at this point? I can't measure it with that. It's not very deep, I'll give you that. Not a lot of penetration. Now I could sink the end mill all the way into it, this little engraving end mill that I have, but it's tapered. It's completely tapered. So I don't really think that's a good idea. Yeah, the end mill might not make it out of this one. This little like $5 end mill. This one might not make it out of this one. Here, let's look at it under the microscope. Let's see what just one drilling operation with the stainless steel stuff did to it. It doesn't really look like a lot. But like again, we want a bunch of the soldering iron to go into this thing so that we get a lot of heat into there, and that's not really going to cut it. That would be just the tip and only for a minute, mind. Or I could lop off the tip, but I don't know where the temperature sensor is. This is kind of doomed, isn't it? Let me see here. Restart to install the latest Windows update. Pick a time. You can permanently pick a time. I'm just going to keep the schedule restart up there. Goddamn Windows update. It uninstalled my graphics drivers. Like, why? Oh shit, I moved that. Well, I lost my 0, so we might as well get this thing out of here now. I won't drill it out with that thing anymore. We'll just deal with what we have and see if we can use that at least as a temporary hot knife. I don't know how we'll be able to lock this thing together, though. Would have been real slick if I could have sunk a grub screw into that. But again, I need to buy a cobalt drill bit in order to do anything to this fucking thing. Holy shit. Yeah, let's look at all of what we accomplished. Three-in-one oil for more than 5 years. Oh, without a doubt, I've had it for more than 5 years. Yeah, that thing is, I don't understand how 3-in-1 oil is able to distribute itself so sparingly to everything. So that the end mill is what got us that extra distance. That's what that lip is in there. Yeah, I don't even know what the age of that they should print a date on that bottle so that you know. Yeah, I've had this since 1975. I don't even remember purchasing 3-in-1 oil. I don't think you do remember the purchase of 3-in-1 oil. It just follows you around. Like an old man dies and then his 3-in-1 oil is inherited. It's like a curse. Yeah, you're absolutely right about that. Yeah, are they still in business? like a demon that won't go away until you fulfill something. That is absolutely not going to fucking work. God damn it. If I could lop off the end and somehow attach those, that would be great. I wanted to do is sink a drill bit this way, at least to get a little bit more of the shoulder in there, so that I could get a grub screw on the side, and then that would lock it into the soldering iron tip. But it turns out I just can't even get any of my bits to go any further than just through the very beginning. And also, this thing will not work. I mean, if I get it this far, a grub screw still can't contain that, and I still need to drill a grub screw from the side, probably from this side, you know, drill through this way. I need a steel X-Acto knife, or sorry, a steel Jello mold. I need a steel scalpel holder, not stainless. Is that even a thing? Let us look it up. Let's see if I can just buy something to do this. And we'll do some kind of a cursed thing in order to hold the blade for now. So I can do. Scalpel handle, solid stainless. Yeah, it's unless I machine my own thing, they're all stainless. The other thing would be a cobalt. Cobalt drill bits for hardened steel. That's what I have, and it sucks. I think all this stuff is just like, what is it? Shit that gets pushed on you, AdSense kind of crap. Like, they say cobalt, but I don't believe them for 1 second. Mine are like that, and they don't work. We saw that thing stop working in front of our very eyes. Oh yeah, sorry. Oh my god. Oh my god. Thank you for telling me. How embarrassing. So these are like the Amazon results for cobalt drill bits, right? Would cutting along the tip of the soldering tip hold? I would cut along the tip of the soldering tip for holding the blade, but you need to have that backstop. I mean, you could like pinch it, I guess, and have the blade fit in. You can also, with the scalpel blades, you can also, here, hot scalpel blades in your area. I spelled that wrong. Scalpel blade images. I saw somewhere, there's that Talon bit, by the way. That would be the one that I'd want to use to cut plastic. Of course, there's a specialty Utah medical device to do this. Yeah, would carbide be the way to go? Hot X-Acto knife. I hate X-Acto, but this will show the examples of what I'm talking about. What is that? They just, for some of these, they just have a block with screws in it to hold it. I can't find any of the examples, of course. That one is a pincher. I don't know why everybody insists on pinching the blades, because it's such a bad idea. You want to key this thing right here so that you can't twist the blade. This guy could, like, cutting the shit out of his own hand. Good work. I mean, what we can do is try to pinch on. I could try to do a steel piece that just has a grub screw locking it in, and then on one of the flat sides, we can do 2 screw holes, and then that can hold it in. And that's easy enough to build. All I need is a little block of steel or aluminum. I guess we probably want steel. I don't know what aluminum would do in the presence of that heat. There it is. That's what I'm trying to build. There it is. The perfect man. That one has a depth. That's pretty nice. Oh, that's for cutting fabric. What am I going to be doing with a hot knife? That's the second part of today. And that is the Bosch anti-lock brake module. You guys come over here. We need to cut open the top of this thing. Inside of this thing is a gel. And the gel holds plastic. Now, I could just heat up the knife with a torch and wear a glove. That's always an idea. But I've got old soldering iron tips, and I would like to utilize the old soldering iron tip with the scalpel blade in order to hold... Where did the scalpel blade go? It's always scary to lose a scalpel blade. Oh, I think I put it on the scalpel. We'll just get a new one. Or did I? No, I didn't. Where did the old scalpel blade go? I need to find just a little block of steel that's going to hold everything. Oh, there it is. Yeah, you can post the link if it's relevant. I think what we can do is we can make this out of steel. I think we have to make it out of steel. I tried to utilize an X-Acto knife holder that I had, and I wanted to attach it to the tip of the iron and have it hold on and be fairly minimalistic. And that would have happened if we could have gone further into the stainless steel. I don't have the right kind of drill bits, unfortunately. It just doesn't hold it. TTP, harddrills.com. Harddrills.com is something that I'm reluctant to open up on screen. Is this stainless steel engineering? No, there's a stainless steel brewing site that I really like. Hold on, let me open this up. Let me open this up. Drill through stainless when installing a reverse osmosis system. Use cobalt bits. That's what I think I have, and it did not really work all that well. Okay, drill bit. Switching into stainless steel, the choice of the drill bit will ultimately determine how successful you will be. Cobalt drill bits are considered the best option. Now, according to what I saw on Amazon, mine are cobalt already. They've got the sheen. They've got that sort of yellow sheen to them. They're coated. So I think we're... okay in that regard. But... you know, steel and screws would take us a lot less time. McMaster's carbide. Yeah. We tried the, whatever the hell coat we have on this guy, and it worked perfectly. The only problem is it's fucking tapered. So, what is this one? This one is unlabeled. What is the blue coating? I thought that was cobalt, but I guess not. We're trying to machine it for this. So the tips are... drill bit, carbide, or cobalt drill bit, rather. Wait, cobalt or... yeah, the cobalt. Okay, cobalt. So we have that. Yeah, we're getting there. Speed. Slower it down. Slowerlier it down. No out drilling stainless steel. No, wait, what are you doing? This is the same thing. Stainless steel will work hard and fairly quickly when heated. That's exactly what we ran into. Hey, Bolvar. Can you offend all the machinists and just plunge the end mill in the hole? I did that. It actually worked. Yeah, so slow down. Drill bit speed chart. I don't care. Pressure. Maximum pressure result in maximum results. Excessive pressure. We weren't making any progress. We got about 1 millimeter in and then it work hardened. Lubricant. I mean, usually we don't use lubricant, but I was using 3-in-1. Sprays and pastes. Take a break. We tried that too. Yeah, we did everything. I think we did everything we could try. I can take another stab at it and just make sure that we're using a cobalt bit. Yeah, there's not much we can do about that. And our afternoon is burning away. All right, let's give this a shot. Let's get you guys back over to the... I really do want to get the whole through this thing, because otherwise we have to machine out like a whole block of something like this. This is steel, and I could cut like a square piece off of this. We could zip off some of the sides, and then I can just make like an offset holder for this that has, I mean, we could even use this part to make the taper in the very end of this hole. And then we could have it sink this entire thing in and have 2 screw holes on the side. We're going to do that. Fuck this shit. I'm not going to drill the stainless steel part. This would have been pretty nice and clean and minimalistic. But I think what we need to do is shave off a piece of the steel and just use that. We'll just use that. I'm just going to fucking like zip this so that we have a flat piece that's about that tall. Well, I think it needs to be tall enough that we can put screws into the blade as well as this thing. And then it also needs to not eat up all of the all the heat. This thing needs to be able to get it hot. So I need 2 screws in that, and then a grub screw from the side for this. So it'd have to be a very shallow screw indeed. But I could take a scribe mark. Somewhere around there. That's a really sloppy mark, but we are just making squares. Scribe mark there, take it all the way up to that one goes there, and then the length of this be like up here. We're just gonna make a really sloppy. I'm gonna need the bandsaw to cut this though. The initial piece can get bandsawed, and then I can whittle it down with other stuff. Oh man, there's a lot of stuff in the way over there. That's all right. We can deal with it. We can deal with it. I have a lot of good chopping devices for the milling machine, so we're probably gonna have to work on this on Friday, though. In the meantime, I'm not driving my car. Or we could just work late today. Urgh. This is my super scientific way to hold up my bandsaw. My totally safe and not dangerous at all bandsaw. Plug that into the same plug that the computer's plugged into. Perfect. Cutting. So I've got sort of a sloppy line here. Maybe I should make it a little bit cleaner. Where did the square go? It was over here. I was looking at it as part of my work alignment, and I don't know where it is. I don't have a lot of off-stream time anymore to work on stuff. I'm really kind of reeling about that. That's why you guys are seeing a lot of these parts of the projects right now. I can't just make a tool off screen. But hopefully this is a little bit more fun than just fiddling with electronics. We will get to the more fiddly part of the electronics for sure, because I need this thing fixed. And it shouldn't be out of the scope of... Oh, I see. It's under the brush. Thank you. Yeah, it shouldn't be out of the scope of the type of work that we're capable of doing here. All right, so I'm just going to square that off there. Get a scribe. What happened to all my scribes? There's one over here. I know when I'm mute. Don't worry. I'm usually the one that's most aware of when the plug slips. So what we'll do is we'll take the cut off of this piece, roughly with the bandsaw, or the portable bandsaw, and then I will clean it up with end mills on the mill itself. Now, the DRO, we don't have the DRO, and my end plates aren't really aligned. we should fix that before we move on. But I'll you know, we can clean it up within itself. That's sort of the whole purpose of that. So I'm going to keep my hands on this side. Yeah, I'm going to use a chicken stick. That feels safer. All right, so there's the part that's going to mount this thing. Animation, robotics, blah, 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 blah. Neat. You'll be able to answer me on this, but I'm studying a major in AI and was considering a double major next year. I think robotics would fit well. AI and robotics? Yeah, I guess so. I don't know, man. My friend had to drill a few holes in stainless steel and he ruined a few bits without any progress. He took to a specialist to use a press to make the holes. Looks like stainless likes pressure and low speed when you want to drill it. Huh. Cool to view on a thermal cam. Oh, I didn't get to see it. All right, back over to the mill. So now we need to square this piece up, and my mill is terrible. So let's see if we can square up these bits a little bit to themselves, and then maybe, just maybe, we'll be able to get them into some kind of a form of alignment. Because I'm going to need to kind of rely on them to be... They're not, though. That's the only problem, is I can't really rely on these things anymore because they've been removed. Is the wrong size? No, it's the right size. Yeah. Yeah, see how they move all over the place? Nah, you guys probably can't see that. You're too far away. You're not up here, like right up against it. And then I need something that's going to make these two parallel with the... We can align it at least on one side, I guess, just by doing this. To the best of my abilities, at least. Oh, no, never mind. They don't move in and out like that. We'll just move them like this, maybe? That might help. Probably not. It's like the least accurate thing I can possibly do. This really garners a full, like, you know, test and measure kind of thing. I need to come in here with the measurement tools and wang jangle the thing into place. Do the full 9 yards, you know? But we're trying to... I was trying to make this only be half of the stream today, so... Hello? There you go. That might help a little. And my little steel block, can't really trust any of the surfaces on it. I can trust that one for now. We have to get that one. I don't know how I can do the ends. I can trust the parallelness of that, but then how do I get that flat? I guess I just have to trust what was there before to be flat. And then that'll help me flatten out my bandsaw cut. My bandsaw cut. Get a parallel bar. The lighting situation over here is bad. And I feel bad, but I'll fix it at some point. That's another wiring project that I just need to get back to. These leave just a little bit on top, so this would be the one that I want to use. Leaves me just a little bit of metal to clamp onto, and then my mostly level surface is that one. So I'll hold that in place right there. I don't generally use a hammer to get this stuff to be totally flat. It's within the tolerances of what I'm building to just do it this way. Not the best way, but it's what I can do. Yeah, that, lock it in. So now we can smooth it out a little bit. For that, I'm going to use a big end mill because I'm making big flat surfaces. Oops, that doesn't even go there. Hold on, I gotta release the drawbar. Release the drawbar. I'll read chat in a second. Hooah! Drawbar, go! Back up. And this should machine a little bit better than its predecessor, but still be a pain in the ass because it is indeed steel. Mild steel. Been watching Gold Rush on TV. These guys have like $20 million equipment floating around, but on a $5,000 lathe to make a simple hydraulic plug. Oh, dear God. As someone who's never worked with machining stuff, you ever get yourself injured? No. Do you have any degrees? Yes. Moving on. Part of it is that I don't pay attention to you assholes when I'm actually doing stuff. Part of his lighting, part of his camera focus. All right, a very small pass. I'm going the wrong way. Nope. Always go the same direction. You don't want the workpiece to be pulled into your cutting edge. You want it to be kicked out. You can see my hands. I don't know what camera angle I got. Yeah, you can. Okay, cool. I don't have a lot of coolant on this, so I don't want to go too hard. Oh man, this is taking forever. Nice and flat surface, though. All right. That's one surface. Oh, let me zip the end too, I guess. Do I want to zip the end? We don't need it to be this long. That's one thing, is that this definitely needs to be reduced in its width. Quite a bit, actually. That might be a bandsaw, another bandsaw operation. I'm going to flip this and flatten out the other side once it cools off a little bit. Yeah, it's an AVE sticker. $3,000 on a torch, $5,000 on a lathe. Yeah, it's, I don't know. Milling and chilling. Yeah, it's been a while since I've milled something, and I'm doing it right now just kind of by the seat of my pants because the DRO does not work. I'm a little angry about that. DRO stopped working. See, okay, if I flatten the one end, I guess that gives us a flat surface to drill from that's square with everything. So we might as well do that. What direction is this thing moving in? That's moving that way. Yeah, this is what... I want to do it from behind to the front. Take whatever innuendo you need out of that. That was a little deep. How does that look? Yeah, it looks pretty good. Okay, cool. So that's two of the faces are now square. And those parallel faces are still parallel as far as we know. So you flip it over. It's one of the first things you'll learn how to do on a milling machine is how to build an inch by inch by inch square and get it as dimensionally accurate as humanly possible. And you'll realize how dimensionally inaccurate humans are. Now that we know that those faces are flat and parallel, well, that one doesn't really look all that good. It still kind of looks a little chamfered, doesn't it? Well, anyway, I know which faces are which. It's whichever ones are still oxidized. So move that like that. Press it down as hard as you can. Oh, that's a little wobbly in there, actually. I wonder if two of these parallel bars is what I need to get it nice and flat. Although there's probably still a burr that it's resting against, too. Yeah, let me knock the edge off of this. I guess I could just do it with a file. Just run it on the file. Just to get that little excess of material off of the end. And to soften the edges a little bit. We'll still be machining those down. But now I can get the edge that we just cut. Oh, which looks like a piece of shit right now. Anyway, edge we just cut down on the thing. On the parallel bars. And then clamp it up nice and tight. These will probably, yeah, those will fall away just because I don't hammer the top of it, and I probably should. I get better accuracy that way, but we're not exactly entering a contest for machinists here. I'm just going to take a very small amount off of the top here. That's going to cut a lot faster than the other side. Go down just a tiny bit. Just make sure that I've cut everything. Looks like I have. Okay, so that's most of the sides. Oh wait, we need to do the end. Let's do the end. Okay. Bop. Just shaving off the chamfered sides of that block. Top and the bottom, I don't really know if I need to do. We can do it if we want, but doesn't exactly need to be done. Okay. Yeah, we should do it just to be nice, because this is a pretty big block that we're going to be asking this thing to heat up. We could probably machine away. I don't want to get too fancy. Let's not get too fancy with this. So I'm doing this. I don't know if two of these are going to fit in here. Oh yeah, they are. No, one of them. Only one. One at a time. One at a time, and get the chips out of there too. Don't want to catch any of them. So do that end. Make sure that's straight and parallel, because, oh boy, doesn't look like it. So it probably isn't. We're going to be making some form of trapezoid here that we're going to be able to put the scalpel blade on. Oops, that's the wrong axis. Down we go. This is my take no prisoners end mill. I'm going to break the edges on all this and then put it back in on the other direction. And then we'll have a nice machined rectangle piece. It's not very flashy, but we're gonna shorten it a bit. Oh wow, the ends are, that is not straight up and down. That is crooked as shit. Interesting. Okay, well, hopefully the next one it's nice and flat. I wonder how that happened. Probably because I'm going quickly. I at least want to get a hot knife out of the end of this stream, you know. I want to do a decent job on the hot knife. So I don't know if we'll break a little different on the, well, let me put it in this way, and then I can do the side cut, because it's like crooked as shit. I don't know how that happened. It might have slipped in the holder, you know, that, or my bars aren't exactly parallel. We had this whole thing apart a minute ago. Let me lock it down a little bit tighter, then give it another little bit of a wrench. Okay, hopefully that cleaned it up. Okay, we're almost there, I think. This is still too much material to expect my soldering iron to heat up, so we'll have to figure that one out. All right, that's moderately square. It's probably more of a trapezoid if you're sensitive to dimensions. Well, that's a noise. Jesus Christ. Maybe I'll use the fine part of the file. Maybe that'll help. And then these edges are harder to do with something as small. This one, and then this one. Okay, let's take a look at this over here. watch the stream and get envious of the equipment. It's taken a long time to get all this stuff together, so it's you know, not an easy thing to get a shop like this going. Okay, this thing. Ugh, ugh, ugh. Don't you judge me. Ugh. Oh, what happened? Oh, it's disgusting. What happened to this edge? It's all over the place. That's okay, we can still work with it. And in fact, we probably will need to cut it. So with the mild steel, we're gonna have a much easier time boring it and doing all that stuff, assuming that I can actually align anything properly, which is a big ask. This is a lot of material, and we don't really want this much material. I don't want this much material. I really just want something that's going to hold on to the end of the iron and then allow me to attach a knife blade to it. So if I do like that, that would probably work. What's that dimension? Yeah, I think we sized it for this, yeah. So if I do that, and then this next to it, like that, we could put a cut here that would reduce the material quite a bit. Put it like there. We could have like the tip of the soldering iron sticking out of the front. Oh man, my hand's cramping. So we'll taper the end of this hole and we'll have a grub screw here, and I'll cut this to here. This is where the DRO comes in handy, huh? Or machine blue or something of that nature. Ow! I can cut my hand on this. Hands are cramping. Why are my hands cramping? It's one time at hand cramp. Because then if I get rid of most of the material, then we can have this just stick out until, like, at the most up here, and then we can have 2 screw holes on it that'll keep it sort of in alignment, instead of having the taper on the back, which would be nice to do, but I don't think I can machine that. Not with the equipment that I have, without using all kinds of weird shit. Instead, I can just have screw hole, and then I can thread them, and then this will be a little bit adjustable, and we'll have our thermal load here, and we'll have this taper up and over. So this will come up and over, and then end as soon as possible, basically. Because we don't want all of that steel sapping all of our heat away. This is going to be a hot blade, because in order to repair my ABS, I need to open up the plastic. But in order to open up the plastic, I don't want to make a big mess with plastic shavings all over the place. So instead, what I'll do is I will machine. This is not going to fucking mark this at all. I usually use aluminum. Aluminum is so much better than this crap. I hate mild steel. Yeah, that's what's sitting in front of me. I can't even see that. Look at that. There's no scribe mark. This is stupid. I hate it. I hate it. Yeah, and I'll just need to lop off like a big chunk there. So let's make that cut first. I could just do that in the bandsaw. And I'll do it by ear, I guess. Not really measuring anything. That's the thing. This part is so small that I absolutely have to use the block of wood. Absolutely, without a doubt. Get it like there. And we'll just deal with whatever I get on the other end of this. Where's the block of wood? What did I do with it? Oh, it's on the other table. Hold on. That mark is gonna walk. Well, the tools will be accurate enough when we get to the right tools. The trick with a bandsaw is knowing when to hold off on the pressure. You don't want to give it the same pressure throughout the whole run, because at the very end, all that pressure is going to suddenly go away and this thing's going to fly out of your hands. So it's about mitigating when the thing flies out of your hands. Know thy limits. Next thing I want to do is put a big shoulder into this thing. So I want to put a big shoulder into this piece. Now, which end do I want to put the big shoulder in? It's not this end. Well, that is a good end to do it on, but this is probably the better end to do the shoulder on. So from here, I need to remove, well, let's get it on the table first. Then I can walk in the end mill. Because I don't have the DRO, remember, I can't get totally dimensionally accurate for measurements on this. We're playing it by ear largely, which we can do for something like this. This is the type of thing that we can do that kind of stuff with. So I want the long end, and I want the end that I didn't just cut with a bandsaw, the one that is square. Actually, I kind of want this end, because we will mill going inward. I can lop off that little end, so we'll get that sticking out just a little bit. I will clamp this. Actually, what I'm going to do is I'm going to put the other piece, our end cut, over here. And that way my vise is not pinching. So we do that. It'll be pressing it, and that won't move because it's the same width as this. Good. Okay, so that's in there. Now, what height do I want to mill out? Well, I want that hole to stick out and have this thing sticking up out of it. Oh, look at that. Okay, so now I know exactly where I'm going to. And I'm going a little bit above the surface, just like a tiny little bit above the surface of the vise. Okay, that's going to be tough for me to get right, but we'll see what we can do. So I guess what I'm going to do is just start walking it back this way until I get to the right width, which is right about here, right? And I guess I want the taper to be in a little bit. Here, you guys get closer, so at least I can see you. You guys get closer. I'm going to put you in focus. Getting more coffee. I don't know. This is very seat of the pants kind of milling going on here, folks. Do not follow in my footsteps. I would like this to go all the way up to the shoulder. I mean, I would love for it to go a little past, and then we'll have enough material over here to run some threads. So if I flatten this all the way out to like there, we could step up the drill bit until it gets large enough for the entire shoulder. Although having it up against that would be okay too, because we're going to have a grub screw coming down right in the middle of that. Okay. Well, I know what I have to do. Just don't know if I have the strength to do it. Because the big fuck-off end mill, I need to figure out where the end of the blade is. And then I'll need to bore down with it. Nice gentle cut there. I'll go just a little bit further to right there. Yeah, that'll be good. Okay. Now I just need to take it down to the height that I want it at. This is going to take a while. It's like a tiny little movement of the wheel each time. Just because I don't want to cut it too crazily. My machine has limits, and that's the amount of force that each of these cuts can really sustain before things start to wobble out of control. And yes, this is a lot easier than just drilling out the stainless steel piece. Unfortunately, at least this way we'll get a lot of contact area to transfer heat. I just don't want this thing to be a huge thermal load because we don't have one of the big heaters on this thing. We have a smaller heater. Not that it has to get to soldering temperature either. This thing can be at, you know, plastic temperature, which is a lot less. What is that in Fahrenheit? What's 260 C and F? Further down we go. I basically have to go until we're even with the vise. Now I'm talking to you guys right now. I can't see chat. I have to turn around to see it. I will check up on you in a minute. Make sure you guys are okay. Not using the stove. Everybody's behaving. My right arm, my left arm is tired. It's so tired. Got a couple mils to go through. I mean, like the measurement. All right, this is getting pretty close. It should be pretty good. A little lower. That's pretty good. All right, so that's one part of that done. Do we need to drill? Well, we need to drill from the other side on this part. So, what are you guys saying? I'm wearing safety glasses. You know, just kind of like rub your eye until the chip comes out. That should do it. That should be okay. My eye itches. God, have you ever scratched an eye lens? I have. Sucks. I hate scratching the eye lenses. It's so bad. It's so annoying. Because then you got a permanently itchy eye for the rest of the night. Break the edge. Spill its blood. Okay, so far, this is our piece. It looks like a little pointer finger. We have enough room on the top there, more than enough room, for a very acidic burp. Oh, I'm gonna die. We're gonna do 2 holes. So one of them will go through this way, and we will tap the one, well, we could basically tap the whole thing, and that'll serve 2 purposes. On this side, it'll hold the blade, and on this side, it'll hold the knife. The blade and the iron. Jesus, what's wrong with me? One's got a paper cut on the white of my eye. God, that sounds awful. One thing I did was I used to get injections in my eye to stop capillary growth. It's a diabetes thing. But anyway, I would get these injections in my eye, and one time he hit a capillary, and it created a blood eye. So basically what happened was blood filled the white of my eye just in that local area. Blood filled the white of my eye, but it didn't fill my pupil. So it was like this really metal looking blood eye. Yeah, that was definitely a drop. Some ghost dude. How did you manage to paper cut your eye? That is a very good question. The way that life can suck answered that. That is good. All right, let's see. So this back edge is, for the most part, what we would consider mildly straight. So I guess I can sort of eyeball where the hole's going to go. I mean, that's not really a tight fit, is it? It's close. It might be too large, but we'll try it. Because if it is too large, the grub screw is going to take up any of the slack. Because we're going to need to go through that with the drill bit, and then I'm going to need to use that little end mill that has the taper in it. We need almost a channel points? Like, what the hell around here is I don't even have 1,000 followers. Give me a break. I don't give you the shits. I'm not popular like those other kids on the internet who somehow mysteriously have thousands and thousands of viewers. Maybe they're funnier than me. That's probably what it is. They're probably just funnier. Usually the case. All right, let's get parallel bar. Well, let's get clean. Okay, good enough. I don't have a lot of shop air, so I can't just like blast everything out with air. Okay, parallel bar. We got our block, our leveling or whatever, our width block over there, and then the piece that we're machining over here like this. That's not going to be straight up and down, is it? Small parts are very difficult to make in a machine like this, because who the hell knows what's parallel and what's not. We'll just get it, get it good enough. This thing's going to be like a 5-year-old drew it. Like that, and this thing crucially has to move. Then I get a drill bit that is just mildly smaller than this thing. That's like the same size, I don't know. Oops, wait, where's the... This thing goes up here. Tighten that in. I gotta lock the drawbar, hold on. That's what these tools are for, the castle nut wrench and this hammer with the square end is for locking the drawbar at the top of the mill, and that pulls up on a tapered, I don't know what you would call it. It's like a tapered piece that pinches and pulls upwards so that it's indexed on this edge, and it also has a lot of friction fit on the rod. Yeah, if I did more YouTube videos, and I need to do that. YouTube is kind of scary though, because like if you use audio frequencies, you get your whole like fucking life ruined. So I mean, that would, you know, one way to do it would be to do YouTube videos, and then you get the outreach and you get the discoverability. I could do that. I need to. All right, I need to also fix the lights for my fucking mill. This is a sorry situation, not being able to see a goddamn thing that I'm doing. I can kind of see pretty well. That, and then we come over here, and I get this one aligned. Problem with doing this by eyeball is, well, you're human. Humans are bad at this kind of stuff. It should be okay, though. You know, there's not going to be a whole lot of room for the grub screw on this side. I wonder if I can just sneak the hole a little bit closer to the edge. That's not moving. That's going to be a little crooked. Yes, make all the innuendo now. Let's get it out of our systems. If they were real farts, how much methane? I don't have anything that's tracking that kind of stat. Oops, there we go. Oh, that's wandering all over the place. Hold on, I need to use like a centering thing on this. That's not working at all. It's the smallest one that I have. I think the one that I used before, which is going to push our hole this way more. Since I can't exactly, I mean, I could do it from the other side, but that drill bit is all over the place on the steel. Yeah, we need to find, hold on. I have a set of these things. What happened to it? It's all the way over there. Hold on, grab it. You're grab it from all the way over there. Reach over, grab it. This stupid thing. Oh my God. Okay, got it. Anytime. Oh. Well, I'm ready now. Okay, actually, we can use the tiny one. That'll help. If I can get it out of this fucking thing. All right, that'll help us center this so that the drill bit doesn't walk all over the place. I guess these are a shallower drilling angle. Usually you'd do you'd punch an awl into it first. I'm not doing that. That's deflecting it to the side a little bit. All right, there's our pilot. That gets us started. Now we can use the drill bit to go all the way through. I had to move the hole further towards the edge just a little bit because the pilot thing was walking. What drill bit were we using? Oh God, I don't remember. This one will do. This needs to be up a little bit so I can get the drill bit in there. What are you guys saying? Oh. You know, I've been to college. I'm sick of those jokes already, you know? For like a couple years, it was non-stop, and I was just like, just stop. Just stop. Oil, 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 a little bit of oil. Oil. I don't like drilling into steel. I just feel like I'm gonna mess it up. Usually I'm right. Yeah, okay, cool. That was a lot easier than stainless. I'll give it that. Easier than stainless, for sure, for sure. Now, I would like to taper the hole on the other side. So I definitely gotta move everything now. Oh well. Oh well, that was fun while it lasted. I gotta break all the edges on this too so that we can get it into the vise properly. Now it doesn't need to be incredibly super duper straight. Oh man, look at how off that is. Oh, it's all the way over to the right. Oh, it's bad. It's real bad. Get mom. Oh, that's bad. Oh, look at how far off it is. Oh, I'm never gonna get over that. Oh man. It's all to the side and shit. Ugh. You guys have a one-track mind, I'll give you that. All right, so break the edge. Break the edge a little bit, as much as I can. And then, God, this is like, yeah, I told you this would look like a 5-year-old drew it. All the holes are gonna be off, everything will be crooked. But we don't have the luxury of the DRO. The DRO, I would get measurements of both sides, and then everything could be aligned properly. It's just not the case here. So, actually, wait, I should test this before. So that on this, that's a nice fit. It's a nice fit right there. That's what that is. So if we taper that a little bit, then it'll stick all the way through. We can put a hole somewhere around here for the grub screw. So yeah, that's what the next step is, to taper this end. Innuendo. Ah! My eye is a little off. Yeah, because of parallax. Because of parallax. Shave the material until the... No. Stop it with your stupid ideas, chat. Sick of you. Sick of this bullshit. You guys know better than this. We don't need to do anything to it. It can just be off. Everything doesn't have to be perfect. We're not on YouTube. I'm just trying to make a hot knife by the end of a stream today, you know? I'm just a guy trying to make his way in the universe. That didn't really do anything. I don't know how far I need to sink this thing. That's probably too far already. I probably went too far in a few places. Test fit. Soldering iron? Soldering iron go. Soldering iron tip. 1 of 3 places. 1, no. 2, no. 3, ah! Inside of the T-slots. Okay, there we go. Okay, oh, this is in the way. It can go a little deeper. Just a little. Don't measure, don't move that axis, move these axes. These are the safe ones to move. Okay. Now it's too far. Now I've gone too far. Or the taper's not enough. Oh my god, it fits like right up against it. It's like almost there. We could probably live with this though. It's a little wiggly actually too. If I did like an actual taper, it might go a little further. Like an actual drill taper. Probably, this is probably good for what it is though. Let's take a look at the other end of this and just see what we got. I mean, I can also do I could do the hand tool to open that up enough. So yeah, let's take a look at this. Over yonder. I may also want to put like a big drill bit on this thing so that this goes all the way up onto the shoulder. I'll show you guys here. Come check this out. No, this actually has a has an index on it to keep it from twisting. So I just have to be careful when using the knife so I don't break the plastic, but so yeah, taper here and then the shoulder here. And we tried to use that tapered bit, but it made more of a like a I don't know how functional that is. That's kind of a weird opening. I could just take a big drill bit and just sink a little piece right there, and that way we'd get the grub screw on the very shoulder of this, and that would fit in there. Because I don't think that taper matches what that bit did. That bit did some weird stuff. Made a nice ring right there. Yeah, let's get a drill bit that's going to match this, and I'll get calipers for that. I'll get calipers out for that. That way we know that we're making the right sized hole. So, caliper wise, this thing is 5 millimeter, 4.9, 5 millimeter. So I just need a 5 millimeter bit or end mill. Actually, I think I've got a 5 mil end mill. Well, now we'll just use a screwdriver bit. And I'll measure how far I want that to go in before I plunge it. So this is 5.5. It's a little big. Let's see if we can find something a little bit more narrow than that. You guys got to move. You're right in my way. Ah, my 3-in-1 oil. No. It's going to fall into the back rooms and then end up at some other machinist's house. This one, 4.7. That's the one I want to use. All right, so there's the bit I want to use. Turn this off. Then I need to get the piece over here. You guys come back over here. Everything's kind of in focus. A little bit. A little bit in focus. That's all we need. All we need is some mild focus. There's a chip in there. I can feel it. These don't have to be the most accurate holes in the world. They should just be kind of close. Because I want the bit to fall just a little bit, the shoulder to fall just a little bit into this. And I'll probably do like, well, I can't really measure a 1 millimeter hole, so I'll just drill it and we'll just see where we get to, huh? We're breaking all the rules today. I think I have a 5 millimeter end mill, so I can be much more accurate about this, but who cares? It's just a little knife adapter, you know? Why are you spending so much time on a knife adapter? What's it ever done for you? Looks about right. That looks approximately right. Oh, it's locked. Ugh. Should be all I need. Whoa. Just go ahead and break my drill bit there. Soldering iron tip is over here. Living on the wild side. It's not that wild. Not that wild. Oh. I'm a real wild one. Wubba, wubba. Oh wow, it's off by a lot. That's okay though. I need a slightly larger bit to get around there, so we need that other bit that I had. The 5.75 should do. There's no way that I'm getting back to wherever that hole was, so let's just hope this one's also a little bit off and works to my advantage. That is, I think, significantly larger. That is not 5. This one's way too big. I need the same size one. Shit, I keep dropping the bits over there. This would be it. This one seems too big, though. Where is my calipers? They're over here. I need basically as close to 5 as I can get. Well, this one's 5.5. The other one was 4.75. It's going to be too big. I don't think I have one that'll work. Yeah, I don't. All right, we're using this one. I'm going to drill a very small, very shallow hole with it. A very shallow hole indeed. And then we'll do the grub screw and etc. The one that I have to tap all the way through. And then I'll do the one in front of that that's going to be a little smaller than it. And I want to align this properly. That should do it. My mic cable drapes down with the path of my legs, and that causes me to move, and then my foot, basically my hips move in relation to my feet, and then it unplugs the cable. Happens a lot. Soldering iron, soldering iron, soldering iron. Where is it? Where is it? There it is. Ugh, gotta get this out of the way. Oh, that's good. Yeah, that falls in there just a little bit. Probably could be a little deeper if I wanted more stability from it, but I don't think I do, because I think I want that grub screw to come in and hold it. There is a little bit of a gap. That is slightly too large of a drill bit. But I mean, it falls in just a little bit, and that's all I want. Because I want the grub screw to grab this, and then I want the heating element here to be the main show. Go a little bit deeper. I'll go just a little bit. To give it a little bit more of a shoulder to sit on. That way I think it'll be a little stronger for the type of stuff that I want to do with it. That should probably be it. That should probably be it. Yeah, I think that's okay. Kind of weird. Kind of weird fit. Weird fit, but okay. Because the further down I go, there's like 3 different tapers in there. Oh my god. Oh, whatever. One day I can modify it with actual machine tools. Okay, get this thing out of there because we're done drilling on that axis. So from there, it just fell off. That was my little balance bar piece. This guy. Let's see. Let's bring it back to the bench and take a look. We got 2 more holes to drill. I have a set of metric grub screws, so whatever size we want to use, and it'll probably need to be the size for this right here, we can accommodate. Now, if I was a crazy person, I would have set that at an angle, and then I could have had this sit up against there at an angle and stick out like that. But instead, I'm gonna have it up here. Probably like this. So there's a nice, because you want to hold on to it probably up here, back here. Now I could remove all the material and just leave this little strip cut out, you know, that piece there in order to actually give this like some kind of purchase on that. I mean, if I had a slot cutter, I could also do this, you know, make it clip in, but we don't have that. Yeah, we're making a hot knife from the soldering iron tip. That is what we're doing. So I want this to be able to slide forwards and backwards, but I also want it to be captured. And again, since we don't have any measurement tools on the end mill itself, we've got to do this by the seat of our pants. 1.5 M1.5. Ugh. I mean, this can be an M2. I was hoping for M2. This can easily be an M2. I mean, if I was really, really good, I could machine a little block and then we could have an M2 at the back. But I'm not really, really good. Or we could do 2 M2s. What I'd like to do is have this hole shared. Like I want to do one hole through here, and that'll be an M2. That'll get an M2 grub screw and then an M2 up here. This I would not like to be M1.5. So how can I do that? I mean, if I'm really under a lot of pressure, I guess I could do that. I could do an M1 from there to there and just make a little box of steel. Guess we've got the space to try it, don't we? Drill and tap a block. No. I think if I leave a square here, I think we might be able to do that. I think I can get away with that. I can leave just a 1 millimeter square. Because all I have to do is zip it, zoop, zoop, and then get the front and then get the back. And that'll be like just a little bit of material. I mean, it'll be like I'm not even gonna measure it. I just hold this in the vise. That's barely gonna stick up in the vise though, that's the problem. Let me see what I have screw-wise. So let me get the grub screw kit over here. Yeah, we're not doing 1,000 degrees, thank you very much. Only 600 Fahrenheit. Grub screws, those are all the way over here. God, this place gets messier and messier as I clean it up. Those are all the way over here. My kits go down to M3, and in some places I have M2s. That's an M3 kit. These go to M2, I believe. Although those aren't the right type of screw precisely. And then grub screws are in this other one. I'd rather they be hex bolts, but I guess we'll do Phillips heads. I don't even know what kind of heat these Phillips heads can take. All right, let's see what we got. You guys come back over here. Was there a 1,000 degree knife thing? Or was, oh, that was that YouTube channel, that's right. they would heat up a knife and like do weird shit with it. That was on the same trend as the, what was it, the tungsten ball? M3. Damn it. I don't have grub screws. Okay, I gotta use the bathroom real bad. I'm gonna pop off. I'm gonna die if I don't go to the bathroom right now. I'll be right back. I'm gonna put up some music so you guys don't get all, you know, all crazy, get all stir crazy while I'm gone. And then we'll work on screwing down the knife to this thing. That's sort of the trick of this whole operation. So let me find where my lead mages go. Nickel ball, that was it. I'll be right back. It's a realistic spoon handle. Fade out the music subtly but strongly in order to create a nice ambience. Okay, that didn't really work so smoothly. It was a little herky-jerky. What was going on with that? Is my computer out of resources because of that freaking GIF? What's going on? Oh my god, get out of here. Maybe it's because it opened it in like 40 tabs. Actually, I want to keep that one and get rid of this one. Okay, let me get a glass of water. Glass of water, and then we figure out where these holes go and what their sizes are. That's the hard part. That's gonna be the trick. Where's the glass? Better have just been water on this glass. Yeah, okay. This is pure vodka. Okay, I'm back. Hydrated. I'm in my lane. I'm thriving. Yeah, so in order to fix this ABS unit, we had to invent a hot knife. And so we tried to cut up a scalpel holder. It didn't quite work, just because stainless steel is a very tough cookie to get through and very difficult to work with. So that, while the stainless steel thing would have worked, I decided to move to mild steel, because mild steel is just a little bit easier to machine. It doesn't work harden. And so in the time that it took us to vet out that stainless steel was a terrible idea, I've been able to make most of what is going to be a scalpel holder block. It's a little larger than what I would have liked. I can always take this thing and reduce the dimensions a little bit. But it is going to function pretty well for what we need it to function as. It'll get pretty hot, and it'll stay pretty hot. It would be nice to put a big old chamfer on the two sides there. And look at this friggin' quarry that I've machined into that. Hold on, what's that over there? That needs to go away. Okay, just a little detritus. So what I need to do is I need to drill one hole through the back here. One side of that is going to have a grub screw or just a regular screw. And what that'll do is that'll press the soldering iron up against the outer wall here, and it'll keep it held in and from rotating around like it is wont to do right now. Now, all things considered, I probably could have put this up a little higher and done some more fancy machining and made this thing a little bit more elegant, but we were going for speed, so this is how it is. All of the holes are crooked, everything is off, who cares? So anyway, I want to do one hole through this, and that one hole on one side will hold a screw that'll hold down one side of the scalpel blade, and then the other side will do a grub screw that'll hold the soldering iron in place. Then I'm free to do another hole here that'll hold a second screw that'll hold down the scalpel blade and keep it from rotating. Yeah, that's mild steel. That's not an aluminum block. I chose steel because of I guess the heating. I don't know. I could have made it out of aluminum. I could have done it out of aluminum. So these I've got M2.5. Does M2.5 fit through the tip of this thing? The answer is no. The answer might shock you, and it's no. The answer is no. We do have M2, and I still think that's too big. Is this M2? Damn it. Ugh. I think M2 is still too big. I mean, it'll fit through the back piece, but it won't go up to the front. My best bet on that is, I mean, what I can do is machine the steel away and leave a 1 millimeter block for this thing to key into. Or I can use two M2s, M2.5s rather, that will just barely fit in there. I have one up front, one in the back. I mean, that'll hold it. I've done that before. I do kind of want that 1 millimeter in there, though. And that's not too bad for us to machine. And this is like it's like a little bit over 1 millimeter, right? Then we'd only need one screw hole through the whole thing. But that is a tough thing to actually machine. Yeah, it's like 1.6. That thing is 2.4. If I do that, I mean, that'll remove a little bit more material and make this thing a little bit easier to heat up. All right, I guess I'm doing it. I'm leaving a 1 millimeter trough in the middle. I don't know where the middle is, though. That's the only problem. CH. Not mashing it. Yeah, the only problem is the consistency, or lack of consistency, that I'm going to get. No, but if I want to keep only one piece of hardware on this, then that's the way I got to go. Because then I can use, well, M3, these are M3. These probably don't fit in the backing there. Hold on. Yeah, so I got to use M2.5, which is unfortunate because my grub screws stop at M3. It's really annoying, actually. Why don't you have M2.5 grub screws? What's wrong with you? What is your problem? Why do you hate me? Oh, yeah, that doesn't work. Damn. This grub screw kit was a ripoff. Shit. Maybe did I get another grub screw? Hold on, I'm going to check to see if I have another grub screw kit. Let's see if I have another kit, because if I can use M2.5 for both of those, that'd be nice. What's that? That is a circlip kit. What am I thinking? It is a second Oh, that's English sizes. Never mind. All right, so we'll use the Phillips head screws, as much as I hate to. And we'll do a 2.5 through the block. And then I'm going to try and do my best to make a 1 millimeter trench in the middle of that thing. So let's get to work. Let's get over here. I'm going to use the big end mill to do it too. Use the big boy. I'm going to use the big boy on this one. I have a lot of light over here. I think we can manage to do it though. I think I can get this right. So what I'll do is I'll get the workpiece first of all. And we're going to put that in here. Shoulder it up. If I shoulder it up at that height, I don't have a lot to work with. But I don't think that's what was preventing me from trying this before. I don't think I'll get anything if I use this one. It's not gonna hold on to anything. There's nothing there to hold on to. Shit. Okay, hold on. Hold it horizontally like this, and then machine it from above, and then flip it over and do the same thing on the other side of the same height. That's a big ask. I don't know why you think I would be capable of doing that, chat, but I guess we'll try. Wait, but then this isn't really going to hold on to it straight because those edges are all fucked up. It's the trapezoidal block of doom. No, that's not going to work. It needs to be machined from above. Well, I guess I can lock it down like this, and then I can put this thing in here. Tighten that up by hand a little bit. Yoink. Pray, hope and pray. Chad, I pray every day that this block is going to hold up like this. It's, okay, we're going to go very gentle. Also, I'm probably crushing that a little bit, but that's okay. We're going to go very gently on this. I guess I'll use a smaller end mill. I guess I'll capitulate and use a smaller end mill on this. Oops. Drawbar. Measurements are anathema, so that way we can drill a singular, little bit smaller than a 2.5 millimeter hole, and I can thread the whole thing from end to end. And that way we have our grub screw hole and our blade locking hole. So this up here. And then I'm going to tighten it. There's no choice. We have no choice. We got to do it this way because I said so. Down we go. Oh god, this is gonna take us a little while to get down here. Crank the knob, crank the knob, crank the knob. Down we go. Down, down, down. Down to the center of all things. I'll take a couple passes and then I'll do a check with the blade to make sure that we're mildly close to the center. Since I don't really have marks on this thing, I guess I could have machine blued it. Nobody's got time for machine bluing. Man, this is in the center right now. All right, whatever. We gotta ruin it. Ruined. Completely ruined. Okay, blade for reference. I want this thing to be like approximately there. I mean, I guess I could try taking a marker, but I think the marker would get me too close. It'll give me an idea of where I am. We'll try it. Try anything. This is where the DRO excels, because the DRO tells me the numbers, and then I can base numbers off of, for instance, the center of the piece. Although this isn't exactly centered, is it? Huh. Yeah, it's like way off. It's like lower on one side. Should it be closer up than down? Why is it the opposite of what you think? I guess because the blade side pokes out of the bottom a little bit, which is good. We want that. What happened to the DRO? Time and usage. It just got worse and worse. the x-axis has failed on it. Something is wrong. It stopped count. It was actually a very subtle failure, to be honest. The x-axis stopped counting numbers in the middle of movements, which is horrible to have had to discover is happening. We were going to modify a camera lens or a camera cover for this camera on the arm so that we could have slightly better protection of the camera, and I could have a plug in the back that won't break and crack like every single USB 3.0 ever has. And then we discovered when moving the x-axis that the numbers stopped ticking. The numbers stopped ticking up, which is horrible. You don't need to tell me about that. I know when my mic fails. Don't worry. All right, so let's get going. Brush, brush, brush. Where brush? Where brush? Oh no, what did I do with the brush that I had? I need to brush the chips off. I don't want to put my hands in there. Where is brush? Brush, 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 brushy, brushy. Oh man, fucking thing's gone. All right, different brush. This one's full of dust. Ugh. That was very close. Take it in just a little bit. That means I want the table to come towards me. It's like this. Nope, wrong way. All right, that's one side, and I guess I'll depth it a little bit more. For our first pass. Now I'm going to do the front side, so I guess I'm not going to change the height. I'm going to move it this way. I should be cutting this from the other end, so I'll take it all the way over here. Can't even see that though. I guess I'll just have to cut it wrong, just because I want to be able to see what I'm doing. We'll do a very, very tiny cut because we're going to kind of like a full depth here. This thing is a lot more accurate. It's taking much more gentle cuts. A little bit thinner. Actually, let me test this before anything else. Before I go deeper on this thing, I'm going to test fit with the blade, which I lost. There it is. It's over there. Okay. Hup. Ooh, that's so close. Actually, it's not. That's way off. I need to take one cut out of the other end, too. I'll take one more pass on the other end, and then I'll shave more off of the front. That might have been too much, but okay. Double check. That was kind of a bit of a deep cut on the other side, but it is a lot smaller than I thought it was. So my impression of the size of the block that I have to machine is a little bit off. That's a pretty snug fit. It's got a little bit of wiggle room, which is probably going to piss me off when I go to use the knife, but that should be good on that. So now I need to cut the front and the back to the right portion, which that's going to be a lot harder than it sounds, is what she said, I guess. But okay, let's start shaving off the front. Far in are we right now? We are here. We are just about where we need to be on the front, actually. Yeah, because that goes into there, and then we can flatten the back end to like there. But let's start taking some cuts in, and we'll reduce it quite a bit. We'll get it close, and then I'll shave it down to be the right dimension, because that can have a little bit of wiggle room in it. A little bit further. All right, let's test fit that. Quick little test fit. Glad this thing is holding on so well in the workpiece. Just like a little tiny bit more. I mean, I could just leave it at that too. I'm gonna cut my finger on this thing. Oh no, I've been messing with knife blades and I've cut myself. I could have never predicted this. There's like a little burr there that's keeping it from sitting flat. Please sit flat. Please clap. I can get rid of just a little bit. Yeah, like fits up to there, and then I mean, while that could screw on, I do also, I mean, one thing that's probably not going to be prevented is the knife lifting up. That's not something that I can really prevent. So I'll take like 1 or 2 more cuts off of the back of this thing. And I guess I can deepen this just a little bit. I probably should do another pass of the whole thing so that it sticks up just a little bit more. Yeah, it needs to stick up just a little bit more. It doesn't have to though, because this will be enough to prevent it from kicking out, but it's not a lot. So I need it to be just a little bit deeper. So far so good though. This is pretty good. This will work if I don't fuck it up. Oh, that's a big shadow. Can't see around that shadow. See if I need to go lower. Every time I redo the cube cutout with the end mill, I don't have numbers, so I am butting the machine up against the very edge of it. It is not an easy thing to do. Oh, I didn't cut the front. To not overcut. Not easy to prevent overcutting. Unless I can really see in there. I need a better light on the mill. I had 2 lights that I put on the mill that would allow me to see stuff, but they don't work right now. I got some bad wiring stuff going on. I need to do another pass on the side. Which side? Looks like the front side. So let's get that all ready to go. Not ruin the stuff I've already done. The cost of screwing this up is, of course, the blade fitting loosely. I don't want that. It's pretty good. Pretty good, pretty good, pretty good, pretty good, pretty good. All right, so now we need a hole for an M2.5 in the back end here. It needs to be pretty centered on, well, it needs to be forward a little bit. So we should be able to accomplish that pretty well. Let me see what you all are saying. I didn't hear that random fart. I guess that was a while ago. Okay, so I need to drill a hole for an M2.5, which means I need like an M2.5 nut, which would be the maker beam stuff. So if I can just quickly grab one, because I want to just fit a drill bit into the nut, and then that way I know that I've got enough purchase for the threads to be threaded in. So nut. Check. Drill bit. Is it going to be another obscenely long drill bit? No, thank goodness. No! I get another nut. Stupid fucking thing. I can't fit in my end mill, my milling machine right now. End mill. I can't fit in my milling machine right now because there's too much like shit around it. So I have to like lean way over to get a drill bit, and I keep dropping them all over the place. Keep falling out. It makes me angry. Are these actually M2.5? I need to check that actually. If they're M3s, oh, they might be M3s. they might be M3s. Those are M2s. We're using M2.5. I'm looking in my screw kit right now. I know you guys can't see what's going on, but I'll be back on camera in just a second. Yeah, I dropped the nut. That does count as a drop. That does indeed count as a drop. Oh, the maker beam stuff is M3, isn't it? Okay, that changes things. So I guess I just got to compare the screw. M2.5 is a very tough thread to do because it's so tiny. It's good for like plastics where you don't have to actually put threads in the hole. Like, you don't put threads in the hole and then it just pressure fits itself. But for something like steel, I need to be very careful because if I use this drill bit, it's going to not allow me to thread the hole. And I'm sorry for leaning up in front of the camera like this, but this is how I'm finding drill bits today. Oh, not this thing. Not this thing. Not you. Not you. This looks like it's almost the right size. I'm not using it, though. It's too big. What about this? Way too fucking big. Way too big. And the problem is at these sizes, if you under drill the hole, then your tap is going to be doing a lot more work and you will end up stripping or breaking your tap. Okay, so this is our drill bit. I'm gonna put it in my mouth. Lift this thing up. Then we gotta get this end mill off of here. This is gonna be a very crude tool when we do end up using it, which will be tomorrow. Can't believe I have to fucking do this, and I don't even know if that's the problem with the car, is the ABS unit. It most likely is. Most people have had the experience, the wonderful experience of having to either get one of these refurbished, if they have, you know, this car, get one of these refurbished, or, Jesus Christ, this thing got stuck behind there. Get one of these refurbished, or, not a lot of people have repaired their own, that's for sure, because it's crazy people like me and you that are doing this kind of job, who feel like, I don't need the proper tools. I got something close enough. I mean, there are no proper tools to do this. This is a very unserviceable unit. It's usually like professional places that take like $75 core charge in order to refurbish yours by doing basically this job. I don't know what we're in for when we open this thing up. We might see a previous repair job. Because how does just that fail? It's kind of an uncommon failure for it to not get a reading from one singular sensor. And if it's a bad module, if one of like the chips in there is bad, then I'm just completely shit out of luck. Which is why we're going to be ohming it out. We got to ohm it out and figure out, because if it's like a bad component, they're like aluminum welded. They're like aluminum brazed on. It's really weird. Yeah, my current car is a 1999. BMW 525i, and it has the Bosch, the beautiful, wonderful, amazing and frustrating Bosch ABS unit that just loves to go bad. It just loves to be bad. If this is being good, I don't want to be good. I want to be bad. I'm a bad unit. So, where'd my blade go? I guess I want it to be centered on the blade. So I'll put the blade in and make sure that that's in the right spot. What did I do with the blade? There it is. I think I opened up a new blade. I should have used the dull blade for the test unit. Right there. Pull this a little bit forward. I want it to be a little bit forward on it because it needs to be able to hold on to the flat spot on the soldering iron. And then this hole is, of course, going to wander. I probably should have used the centering thing on it. Actually, yeah, now that I've figured that out, I'll put that on. Yeah. Yeah, you know, we're not doing all of the right steps, but where the fuck did that go? That is so gone. Okay, I found it. We're trying to do some right things, you know, just a few, maybe not all of them. Okay, where are the tools? They said they'd be here anytime. Okay, there. You know, you make promises that they can't keep. Is there any way to functionally test it without sticking it back in your car? I could. I don't know if... So if I can... Yeah, I can. If I can use the CAN bus tools that I have, we might be able to hook it up to the OBD stuff that I have and then go into the specific module. But I don't know. No, because there's other communications that occur in order to make sure that your car isn't stolen. So I don't think I could do that. So I don't think I can do. We can bench test it. Why is it so far off? Not the end of the world if it's off, but am I blind? I think the light in here is just deceptive. Hold on. No, that thing is not. That is not centered. What are you doing to me here? Do we bend it on the stainless steel? Did we ruin this bit already? Is it? Huh? This thing fucking bent? Hold on. Oh my god, it's all over the place. I think it's bent. What the fuck? Is my... Nah, my shuck isn't bent. It's the kids who are wrong. How can you... No. There's no way. Let me try the other side. Like, it's like wobbling on the end. It's like moon wobbling. Ow, I just poked myself in the finger with the X-Acto blade. People always talk about the tank that I gave a knife to. It's like, dude, I've done worse to myself with knives by accident. But that one's a little bit better. I wonder if this is bent. Can't really tell. I'm not really good at this. Yeah, it's probably fine, right? This is why I trust numbers over me. I'm not good at this stuff. I always get this stuff wrong. Whereas when we use the DRO, it's always machine perfect. It'll all come out in the wash, I guess. Hopefully it'll all come out in the wash, because we got a lot of wash to do, chat. Got a lot of wash to do. That's good enough. Okay, so that'll guide our bit. And our bit is this tiny little drill bit here, because we can only use M2.5, and we got a thread all the way through the whole thing. Threads that go all the way down. All right, let's do this. Knife goes back over here. Numbers add up to nothing. You guys have some weird references, man. Yeah, I think the what is it? The vehicle lockout system will prevent me from testing it, bench testing this. Oh, maybe that's why it's crooked. Huh. Lube, I've never heard of him. Now, hopefully that's not too small of a hole for me to thread with an M2.5 tap. We will be using oil for the tap. But this looked like the shaft size of the M2.5 screw, so I'm hoping. But that might, if it fights me too much, I might have to back out and use a hand drill to open it up a little bit more. Wait, I don't need to release anything up there. I don't need to do that. I just need to release this. You are free! Okay, let's take a look at what we did so far. And we'll take a look at the, hold on, I need my taps. Probably need this little thing too. Well, we'll wait on that. Okay, let's come back here. All the edges are like super duper sharp. Yoink! Back at the desk with his proper lighting, finally. We can see what we're up against. So we've spent most of the day building a hot knife, and you'll see why when we actually get to work with the hardware on this thing, because it's kind of scary. the hardware, oh, it's off by so much. Oh my god. Okay, anyway. I think the maximum, we couldn't use M2.5, right? Unless this is M2, uh-oh. I might need to enlarge in this hole. That's M2.5. No, this will hopefully tap out to M2.5. So I need something to soften that edge up. Probably have like an end mill that I can just put on it. Yeah, here we go. This one will do. A little inscribing end mill. Just use that taper to my advantage to knock this thing flat. It's not really knocking off. These are pretty fragile bits, actually. I shouldn't be doing that. That was a really fragile one. This one's a lot less fragile. Nope, okay. I'm poking the back of my hand with it. Where is my file? There it is. So this trapezoidal, largely horribly dimensioned, three-dimensional object is going to be our hot knife. And the purpose of that is to open up this Bosch unit, which is pretty complicated inside and pretty fragile inside. I want to be able to melt the plastic and just put a slice all around that box right there. Getting in here is not going to be easy, and that'll be kind of the hat trick of the whole thing. I don't know how we're going to be able to do it. Maybe by inverting the whole tool. But this is not incredibly well made. I'm not great at this kind of stuff. But hopefully what we'll be able to do is hold on to the X-Acto blade and heat it up with the soldering iron. And that way the plastic will have no chance of actually surviving anything we put it through. So we need an M2.5 tap, and I believe it's these. Let's take a look. M2.5, that's the one we need. Okay, we'll put a drop of oil on this, and then we'll tap it all the way through that. And I'll use the vise to help me get a little bit of torque. The vise and the tap handle. Taps are something that I don't cheap out on. There's a lot of tools that I cheap out on, but not taps. Not after the accident. All right, so like that. And then 3-in-1. There's 3 whole uses for this oil. See, this oil isn't too full of itself. It's not like WD-40 that claims it's got 1 billion uses. It says 3-in-1 oil. It's got 3 purposes to it. Oils are very specialized. We've got a lot of different oils for a lot of different purposes, and WD-40 does not actually do the things that people say it does. Because boy howdy, can you fuck things up with WD-40. You can really mess stuff up with WD-40. Oh boy, this isn't taking an edge. Please take an edge. This is maybe where I should have used a machine tap handle that's able to have like a pin in the back of it that centers it. Although these little ones don't let you do that. So that feels like it's kind of starting to tap in, but it might need a slightly larger hole than that. Yeah, it definitely does. It should bite in after the first couple turns, and you should feel a significant bite. I'm used to tapping aluminum though. I need a slightly larger drill bit than what we use. So I'm going to take the calipers, and I'm actually gonna go over to where the drill bits are, and I'm gonna compare them all. So the one that we drilled it with is 1.8. So I need slightly larger than 1.8, and I don't want to go too far. And I mean, there are tables for the sizes that you're supposed to use. It's just whatever I'm able to actually find. You can see here how I have to climb on all of my hardware in order to get to where all of my drill bits are and find just the perfect one. I think I had just the perfect one, and then I snapped the ever-loving fucking shit out of it by accident because I was being brazen with my drilling. Problem is your eyes start to play tricks on you when you do this. Start to see ghosts. Like, for instance, that one's 2.7. That's the wrong size. What are you? 2.42? I want closer to 2, but I'll hold on to this one. I think I need to get a whole new set of drill bits, to be honest. And then I could at least organize it and be like, hey, M2.5, you need this drill bit. And I could just point directly to it, like a big penis or something. 1.75 is too small. I just use the hand drill for this, by the way. I mean, if I start with this size, no, that risks stripping it. But this in here, this is a weird one. 1.6, nope. Let's go 2 millimeters. Let's fucking go 2.48. That's even larger than the one that I have in my hand. A couple of them drop down, but I don't think those are the right size. I'm like reaching all the way up here. People are like, I see your underwear. No, not that one. What's this one? 2.7. Really? Am I going to have to use this giant 2.3? Ugh, the giant drill bit seems to be getting closer and closer to the right size. 2.7. Yeah, 2.3 is looking like it. That's probably too big, though. All right, let's see what we can do. The right one is 2.1. I'm not getting close to 2 millimeters. That's the problem. I'm finding everything but. This is 2.4. That's absolutely out of the question. 2.3 to 4. I just got to find something closer to 2, huh? Yeah, we'll go back to face cam again. Groovy something for 47 months. Groovy something. Thank you so much for the 47 months of subs. I really appreciate that, my friend. My friend. That is very kind of you. I need a 2 millimeter drill bit though, and I can plainly see that you haven't given me one, so I just don't know what to say. 2.6. God damn it. Come on, I gotta be able to find the right drill bit in this fucking thing. In this world. Why everybody betray me in this world? Okay, hold on. Still looking. 2.6. They're all 2.6. I hate to break it to you, man, but they're all 2.6s. You're never gonna get the right drill bit at this rate. My eye for the size of the drill bit is also kind of off. 2.35. They're all just off. The problem is a lot of this stuff comes from like the bargain bin of the machine shop, and the bargain bin in the machine shop is filled with all the sizes that nobody uses, because the sizes that people use are the ones that break. That one's a 3. That's why I like to work an M3, but the damn scalpel blade won't let me do that. Curse you, scalpel blade. If only there was a better way. 2.7. Ugh. I'm out here doing my best. I'm on my hands and knees looking. 2.7. This stuff quite looks like the right. What is that one? 3. Exactly 3. These things suck. I mean, I can try the one that's very, very close and just a little bit off 2.5, but that would mean that the threads won't have enough material to really link onto and create a good amount of pressure. And since we're going to be heating and cooling this thing, I mean, this one's 2.35. That's 0.2 larger than what it's supposed to. It's supposed to be 2.1. I don't know if I can accept that, though. I don't know if I could accept that into my heart. This one is too big. Yeah, 2.7. I might use 2.334. It'll be easy to thread, which is an unfortunate thing. Print a block to keep your taps. Yeah, I know. That'd be awesome. I was thinking about doing something like that. It would be a lot of very specifically sized holes, but it would be beneficial to have. You can put magnets on the back of it so I can like stick it to something, and then also have the magnets hold the drill bits in and the taps. All right, we're gonna where's my hand drill? There it is. I'm gonna hand drill this. Hopefully not totally mess everything up. And if we do, I don't know what to do. If we do, I don't know what to do. We're gonna rage quit. Fun, right? I just wish I could find a slightly larger drill bit. It just doesn't seem like I have anything like that. Okay, there's that. I think I put another apprentice mark in the bottom of my vise. My vise. Okay, let's go and get another tap. Well, the same tap. If that fell through, I would have been so mad at myself. I think we'll get some taps on this, though. Where did my oil go? Oh, all right, oil's far away. Yeah, it's going to be a mild fit. because that's pretty easy, what I'm doing right now. Well, luckily steel can hold a pretty good thread, but I don't like my prospects with what I'm feeling right now. The way that I feel is betraying me, especially considering this has to be heated and cooled. Almost there. We're out of focus. That little bit of oil that I left on this thing was enough to get it to smoothly tap, but I'm still a little off put by how easy that was. Now the hardest part about tapping, well, getting the sizing right is everything in tapping, right? And then everything should kind of flow properly, especially on steel. But the hard part is when we get to the end of this tap, keeping it from damaging the threads. So you got to kind of lift it and keep it level at the same time towards the end of the threads. You got to keep pressure upwards just a little, but if you pull too hard, it's going to damage your threads. It's a balancing act. I'm failing at. Wait a minute. Can't let it go at an angle. Got to keep it straight up and down. Whoa, I don't like that. Careful. It started to cross thread. Now this is where I probably should do it by hand. Oh, instead of having this whole heavy balance bar on the back of it. So now, with a screwdriver. Oh god, it's so close to not working. Okay, I can get that hand tight. Good, good, good. That's our part. I think we just finished it. I'd love to do some finishing touches on this thing. Oh my god, what happened in there? We need to break away all the little machining mark stuff. Get all the chips out of it. Put it in a what is it? Those things that like roll it with a bunch of hardware. Or what do? They've got it in like a bunch of like abrasive cones and it just vibrates. We're not doing that, but still. I'll take the fine tip of the file and just go over everything again, soften it up a lot before I get the oil. Well, I actually want to keep the oil on it. I don't have any kind of a coating on this thing. Can't exactly anodize it. But I'm going to really soften up all the edges. And then we'll install it and see if it works. We're not going to cut this thing up today. We'll do that tomorrow. That's a tomorrow job. Jesus, these are sharp edges. In software, we would just have to point to all the edges and say, hey, put a chamfer on that for me, bud. Software's like, yeah, man, I got you. Ow! Now, we've looked it up. You can go back and forth with the file. You don't have to worry about going in one direction. That's just a bunch of gatekeeping nonsense. Gatekeeping nonsense. We don't have time for that kind of crap here. This hobby is already weird enough as it is without us keeping people out of it. Because they're holding their file wrong. Like, come on. We got better things to do with our time. Like build weird hot knives. And give them really soft edges with a file, you know? We don't have time. We're too busy filing. Man, steel's a lot different than aluminum. And because we did this quickly, this thing is like the most trapezoidal part ever. This is like a stylized 1990s N64 game where none of the angles meet up. Here, take a look at it up close. So this is the piece that is going to fit onto the end of the soldering iron, the old soldering iron. Oh my God, look at that. Look at the threads in there. There aren't threads in there. Okay, there kind of are. Oh, that's embarrassing. It looks like there aren't even any threads. Oh my God. I mean, the screw found some kind of an edge to hold on to, but oh my God. Yeah, the Cartoon Network aesthetic. There you go. It didn't stick in there. Oh God. That makes me sick. That's making me ill. I feel ill. It's okay. It's okay. We'll get over it. We're gonna put it on the tip of the soldering iron and see how it does thermally. I don't think I have any car equipment to cut apart, but we do need to test it on stuff. Yeah, I don't. The tap found something to tap, but I didn't have the right drill bit size. That was a big mistake on my part. That should have been a beautifully tapped hole, and it just it looks smooth. I'm just angry at myself when I do stuff like that. You know, rush a little bit too much with something and then end up screwing myself over, losing 3 hours of work. Copper wire, maybe. Yeah, I could throw in a little bit of motor wire. Teflon. But it's not about snugging up the hole. It's about the threads not being there. Why does it look like there are no threads? Because there are no threads. But I ran the tap through and it seemed to tap it, so I don't know. Well, let's just see. Let's see if we can actually get like pressure on this and actually hold everything together properly. Yeah, because that'll hold that just fine with a mild pressure. Let's see if we can get this side in. So this, well, this is like, everything's so small. Hold on. Let's move over to where we can see what we're doing. And maybe we just didn't catch the light right to get the tap on there. You can always use the next English size. Where's my, hold on, let me put away all my taps. Get that up in there. Come on, there we go. Oh, man, what a pain in the ass. I hate it when that happens. I don't know what happened to my 2mm drill bit. Maybe it would stand a reason if I kept looking for it, I'd find it. Now, the grub screw, if I can't get enough pressure on the grub screw, I can maybe put it up to M3. But I don't think this is going to require a lot of pressure from either end, because this thing will crush. This is just, you know, thin sheet metal. Just try to clean up all of the collateral here that we've had. The plate idea probably would have been better, though. Because that way I could drill the plate and have just like one sheet of metal on the iron. Also need to vacuum my milling setup. Okay, so hopefully there's enough threads that I can get some kind of a grip on this. I don't know what it was gripping before, because I certainly don't see any threads in here. Maybe those are very subtly threads. Those are threads. Maybe I'm just not catching the light properly. All right, so the soldering iron in like this. And that fits all the way up and a little bit past the hilt. Because I believe that the heater's right here. So that is then going to clamp down right there. It's a little close to that shoulder, but I think we should be okay. So with that, I need just a screw that's going to go into the bottom. And I think it could be much shorter than this. This is too long. They both need to be very, very short. So this would be M2.5 by... Oh, they just get longer and longer. Hold on. There should be a very short size in here. A very small size. That would be this one. Grab one of these. Yeah, that's the size. Okay, well, okay, try it. Push comes to shove, I can also shave screws down in order to make it happen. Yeah, I really wanted to have nice thick threads on these things, because then we would have had a good amount of torque going into this. Honestly, this could be replaced with an M3 if I need to. Ah! Why can't I do anything right? Hold on. Let me twist it this way. That'll relieve some pressure on my wrists. Also, there's no taper on these, so... Yeah, see how it falls in? Oh, I hate it. I hate it. I'm so mad. Oh, wait, that's the wrong side. Well, we need that there anyway. This one at least had slightly deeper threads. Hello? Oh, I see the magnet. It's all magnets interacting with one another. Like, it's pretty tight. Doesn't allow it to twist. I can then adjust it. The only problem is whether or not this side can actually go down far enough to hold in a blade. And it can! Ha ha! I am the wiener! Okay, hold on. Let's put this thing on here. Yeah, it's got that 10 amp blade on it. I don't have a taper for the back end to hit up against, but the screw should provide enough pressure to keep this thing in place. We did this in the sloppiest possible manner, but I believe that this will get the job done. The only issue that I would have is that there's no shoulder for the front of the blade to lock into. So it's going to be a little bit more difficult to get the blade in the right position. And then when you start cutting, you've got to be careful not to pull away. That's why I wanted to use the actual bespoke holder, because the bespoke holder is specially engineered. So you pick up this side, you push it forward, you can see somebody used a slot cutter here in order to make that. And there's a little taper to it that holds the blade in place, and that keeps it very, very stable without using any screw hardware on it. But I don't have a slot cutter. You go fuck yourself, Chad. You fuck yourself, pieces of shit. Yeah, anyway, so without that taper there, I can't get exactly the scalpel feel, but close enough. So if we cut this way, it'll pull away. So mainly, I just want to be working in the direction of the blade, because that'll be held by the screw and this front piece here, and it'll hopefully be kept from twisting by this screw here. Bada bing! We made a new tool, and I think I did a decent job of it. I hope. I mean, the proof is in the pudding. We'll have to see whether or not it works tomorrow. Screws, I need to keep organized. Done. Perfect. Got it. First try. Let's heat this thing up. Well, let's first put it in the soldering iron and see that it's at a good angle. Well, it's a circular tool, so I guess it is. So how does the tip of the blade hold heat? No idea. Do I need another screw on the front? Also, no. Ow! No idea. Look at me, I made this knife, and I've got all these cuts to show for it. Let me get a piece of plastic. We need a piece of plastic to test it on that's not this. Because this is the $200 elephant in the room. But all this to save $200, right? I don't think I made that much on these streams, so... It's like $200, $250 to send this in to somebody for them to repair. So, derelict plastic. Well, we can try it on an Omnipod, I guess. Let's do that. I got, you know, a new one of these every 2 days, so we might as well give it a shot. It's a good prison shank, at least. We've created the opposite of art today, chat. We've done something horrible. We've created something terrible. All right, let me turn on the soldering iron. Boop. Now this is going to heat up. Hopefully not explode. It is heating up, and there's smoke coming off of the oil now. I probably should have gotten the oil off of it first, huh? Ardent. Oh boy, that's getting to be a little bit of oil smoke. Okay, I gotta turn it off. That's too much oil smoke. We have to get the oil off of it. It's a little bit more smoke. What does it smell like? Yeah, it smells like burning oil. Why am I tamping it like it's a I don't think I want to dump water on it. It's probably a bad idea. I just have to let it cool down and fill the room with oil smoke. Yes, well, there's something to be said. I'm baking in my cast iron. So I'm worried about the tip of this thing not getting hot enough. I mean, we can see a little bit of the heat transferring into the stainless. Not a lot of it. I mean, we have surrounded the main operating area of the knife. So once I bake off the oil, we can maybe utilize this thing. I think it'll be okay, but that steel really does hold on to that heat for a while, doesn't it? But I don't think the tip is going to hold on to a lot of heat. I don't think I'm going to be able to use the very tip of the iron. I think I might need to snap it off with a pair of pliers. Yeah, the blade is stainless and the block is steel. What of it? What am I supposed to do about that? There's not anything that I can do about that. I'm gonna let it cool off, and then we got to get the oil off of it. The smoking gun. Yeah, so far nothing. The heated knives that I saw didn't use this style blade. I mean, a hook blade probably would be neat, but what they used is a very stout blade, because you want to get that heat into the blade. Having a thin blade means that it's going to be dissipating a lot of that heat. So, and then also the effect of heating the stainless steel probably would be interesting. I don't know if much will happen. This is 600 degrees Fahrenheit here. So out here, I don't know what we're going to get in the end. There was a lot of smoke just then, so I just want to kind of let that dissipate a little bit, and then we'll turn it back on. No, the blades are not tool steel. Not even, I don't even think X-Acto knives are. Maybe they make the heated blades out of tool steel. This one is not. This is a toasty stainless setup. Is that gonna start? It's gonna start smoking again. Look like a real jackass if you're unable to melt plastic, buddy. There should be no reason that... Oh, Jesus, that's a lot of smoke coming off of this thing. I have to open the window when I'm done here. What is this, thermoplastic? I mean, this part is probably able to melt it. No? The iron blade is. The iron tip. We might be losing a thermal battle here. What about a Dremel blade? Well, look at the title. Maybe I didn't put that in the title, but we're trying to utilize the soldering iron to heat this thing up. Yeah, the blade is acting as a heat sink, but I mean, eventually this will catch up. You can see the oil starting to stain the steel. It might conduct heat poorly, but it is getting hot. That's the point. I'm going to tighten it up while it's at temperature. Pretty good. That's pretty good. Yeah, it's possible that a more blunt edge would help. Corner of the ABS. Take just like a invisible corner down here and see if I can just... Nah, same deal. Well, actually, it is cutting it. Without much effort. Yeah, I did get a pretty good purchase in there. I got a little bit of it. Smoke on the blade. Yeah, that's the band I was in. I played bass for them for a little while. I'm trying it on this thing just because I get a lot of these things in the mail. Yeah, if I shorten the blade, this is actually cutting in. Here. See that? A little bit of pressure, but the hottest part of it is going to be closer to the tool. And so maybe I need to shorten it up a little bit, because look at that. It also takes a minute for all the heat to get into it. It's a 300-watt soldering iron, but it still has to kind of fight. Also, that's not exactly helping heat transfer over there. Like cold butter with a cold knife. An even colder soul. But it's not, you know, it's not a fucking lightsaber. Might be that I need to do another screw in the front. I might just need to do that, just to hold it against the steel. Yeah, that's pretty poor. I mean, it's a 600-degree soldering iron. I should be getting some heat. So a different scalpel blade would also help. The steel, stainless is not great at conducting. It's better than, no, it's fine. It's fine. The stainless is fine. It's just, you know, it might not be able to get all that heat all the way out to that tip, because obviously we don't have steel going all the way out there. You know, maybe if I kept a bunch of that steel in the front and like tapered it off, we could have had like an iron sitting behind this thing. But it is getting through plastic, and I guess that's all we can really ask for. Look at that, the steel is now bluing. I blued my steel. That's refraction on the crystal structure. But it ain't getting through this thing. I don't think this is thermoplastic. This part's been in my body. Can I cut that easily? Oh. Clunk. Well, that was just the blade. Yeah, I don't know what the hell steel this was. This is just shop scrap steel. It's pathetic, whatever it is. They probably smell oil upstairs. I gotta be careful. As the heat gets into this thing, though, it gets a little bit more effective. I'm putting a lot of pressure on there, too. So it's not magical, and it's not shocking, and it's not amazing, but it is effective in some way. I'm able to at least get some heat into it. It could probably do with, oh, it's bluing over there, too. It could probably do with a, something to bring the heat a little bit further up. Obviously, if I was building this thing, I'd be putting, like, the heater, like, here. Yeah, and I could maybe, like, preheat it. I don't know. I gotta be careful not to put too much, oh, yeah. There you go. I have to be careful not to put too much pressure into this thing, because it will slip, and then I'll burn myself. Because this is just a repurposed soldering iron, you know? All I'm doing is strapping this thing to the end of my soldering iron and go, woohoo, let's go! It's not like it's a bespoke tool. Oh, good, I'm cutting into the battery side of this. That should be safe. Also, this thing might not respond to thermal as much. What about this part? I feel that biting in, but it only just bites in. See that? That's all I get. Like, that wasn't bad. Not exactly a fucking Evangelion knife, you know? We'll have to work on that. The blade is taking the temperature, but you can see where it's tapering off towards the front, huh? So if I snap the blade, then we'll get more of a blunt cutting instrument. But again, we're not getting to iron temperature on the steel or on the stainless steel. Having a bit of trouble with the heat transfer on those. All I want to be able to do is cut a clean slice into that ABS over there. So this is only just kind of hot enough to cut, huh? I don't want to pump up my iron temperature either. I don't adjust the iron. I leave the iron at the same temperature. So thermal paste between the, nah, that's a little too civilized. And the steel block is doing well enough. If I just sharpened this to a tip. Yeah, it's losing a lot in the transfer. Yep. That blade is acting as a big heat sink. So yeah, as soon as it bites in, it starts to cool off, which is why I will need to remove most of the tip of the blade and then just have a blunt cutting thing at the end. And that way I can get through the ABS without it losing a ton of heat. I love how it's bluing itself. What's going on there? I thought this is like pretty mild steel. I didn't think it was like that low temperature. Well, I'm not about to remachine it out of aluminum. I'm not about to do that. This is sort of more or less a partial fail, but also we can work with this. You know, as long as I can, actually what I can do is I can snap the blade to be the depth that I want to go into the Bosch unit, and that way I won't be able to go further if I keep this block away from things. The screw in the front end of it would have been a better idea because that would have held this thing together more, or have a block with 2 holes in it that could squish this blade in. But then again, if you do that, you need to have the screws go through the middle. Otherwise, it'll kind of, you know, move up and down as you cut. Because I'm putting some force into this thing, and I don't want it to walk around on me. You know, the tip is still hot in spite of other things going on here. In addition to that, using one of the larger blunt tips of the soldering iron, one of the high temperature tips, the ones that, oop, hold on. The ones with the bulgy, these things, the ones with the big bulge at the tip, they have a much stronger heating element in them. Those would be able to transfer a lot more heat into the blade itself if positioned correctly on the thing. But again, we just came up with this in like 5 minutes today, just screwing around. So please, hotter, could you slightly pivot the blade at the screw using the other end, even if it's not sharp? Pivot the blade. I mean, that's kind of what I'm doing. I'm cutting from this back end. I can still do that. So I would like to pop off the front of the blade, and that way I've got just that little blunt end that I can work into the plastic and open it up with that. Because it is pretty accurate the way it is. I mean, let me try breaking off the end here. And I got a hot soldering iron blade sitting around. That's the only problem with that. Those break really easily. The stainless steel is not an incredible material. Just like that. Now I've got a hot iron cutter. Not as effective still, but it does do something. I've got to put a lot of pressure into that. I got to ease up on the pressure and just go slow. Yeah, so that'll take a couple passes. It still's cutting a very clean line into the plastic though, and I don't know what temperature this plastic is. I don't know exactly what kind of plastic it is. Of course, the closer I get, the closer the tool gets to contacting it. This is the best that I can do, guys. The best that I can do without involving one of the hotter iron tips or redesigning the blade holder. Yeah, it needs to like stick to the front. Oops, that's contacting the vise. I can't even get through this. This is pathetic. This is pathetic, chat. This is pathetic. Welcome to Pathetic Stream. Yeah, it's okay. All right. So, in the future, I gotta be wary of when my that's like it's like a kneeling. I gotta be wary of when my larger soldering iron goes out of commission, because then that will be the one that I can attach. I don't know if for the Pace soldering iron you can buy just like dead tips, Or I could just buy another high temperature tip. I could buy another high temperature tip and just use that one or the old one and modify it. Because I don't think the old ones that I have fit in here. I don't think they work. I need to use the blue ones specifically. But like an iron tip like this that has a much larger heater in it, if I make a more low profile block, that'll hold that blade a little harder to everything. I think that's the secret to getting this exactly right. However, we are going to try to use this tool, what's left of it. I'm going to turn it off right now. We're going to use this tool on that ABS module, and it's going to take a little bit of a little ingenuity for us to get through it, because everything that this touches is going to become a heat sink for the blade. It's possible that I could use the propane torch to heat that up a little bit more, and then we've got a little bit more heat. And we're going to cut along this edge in order to free the top from the rest of it and have a professional edge around there and not have little bits of plastic everywhere. Super Volcano 80-watt heater. That's not what I'm... No. I'd rather it be one of my soldering iron tips, and then I can just, on a temporary basis, slot a blade onto the end of this thing, cut stuff. That's what I wanted anyway. I don't know if we'll be able to do that. We'll try. We'll try again tomorrow. All right. We'll chat. That's it for me. About quitting time. I'm going to pass out because I've done too much today. I almost kind of completed a part of a project. It was a project in and of itself. I expected us to be able to work on the ABS module as well, but some of the modification stuff that I wanted to do to the stainless steel scalpel holder, the one that was like perfect for the job, didn't really work. Stainless steel, turns out, kind of sucks. Yeah, this is the part one. Tomorrow we will try to cut open the Bosch unit. We'll try to control what we're doing so that we don't totally and completely screw it up, because I want it to be a fairly sterile process. This is an important thing. Anti-lock brakes are very important in a car, and we need to take a look at one trace on this thing to see whether or not there's continuity on it. Basically, the reason that this happened, in my opinion on why this happened, and the reason that I had shaking jello during the break, was that I believe that Bosch, in its infinite wisdom, decided to put this gel substance on this high temperature circuit board. And as that circuit board is held vertically in the engine bay of a car, everything's shaking. And even that gel is shaking. Even though it's pretty viscous, it'll shake a little bit like a jello mold. And when it does that, even the ductile gold wires that they use to bond everything together will shake. This is like an experiment that they decided to put into a bunch of consumer cars. Like, why? Why did they do this? We saw it in an industrial solid state relay, but an industrial solid state relay is not supposed to exist in a shaking engine bay. It's not supposed to be there. It's supposed to be in a control cabinet off in a safe spot and be exposed to like heat and stuff, maybe a little bit of environment, but not really, and not be shaking. So I don't know what Bosch was thinking in this regard, but anyway, they all lasted like 100,000 miles, and then everybody started getting weird intermittent problems with them. So what we need to do, my one wheel speed sensor isn't working. I have traced it all the way back to the module. 99% sure that the module itself is what's failed. And then if the module's having problems, there is a 99% chance that the problem is the bonding wires. If it's not the bonding wires, I'm SOL, because the chips and stuff on there, totally unserviceable. They're bonded to a ceramic substrate. So, all right. Anyway, thank you guys for joining me. I don't have too many suggestions on where you should go. I saw Flatulent Gun out streaming. I missed that one last night. But you guys have a good sense of Twitch. All you guys are from somewhere else. It's not like I'm pulling you guys in from YouTube and I need to like direct you to other creators on this platform. You guys know the kind of stuff that there is on Twitch. Hopefully we get this hot knife thing solved. We'll look at it tomorrow, same time, same channel, all that fun stuff. Can't go too late tomorrow, but we will hopefully be able to pop the top off. A good sense of Twitch sounds like yeah, it does. Yeah, it does. Well, it's a curse that most of us have to deal with, but I have an adorable puppy upstairs that I need to go say hi to. I probably smell like burning oil because of that fucking outgassing that we did. And then I can't drive my car for another day, so that's fun. That's fun. We're having fun. All right, I will catch you guys later, and take care. Abs for what? Hmm. 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 Hmm.